Hello, my dear students. Hello, Narumirandiriki. I hope everything is going well and good. Sorry, Cheppandi, is everything clear? Is my audio, video all clear or any problem? Please check your video audio system and inform me, is everything clear or not clear? Cheppandi. Cheppandi, is everything clear? Good afternoon. Okay, very good afternoon to all of you. Okay, with that being said, yeah, fine. It's okay. Thank you so much, all of you. Thank you so much. So, in class, we are going to see an interesting chapter, electromagnetic induction interview. Okay? Sir, what do we say in it, sir? Future doctors. You start with the mechanics chapters, okay? Mechanics, basics is your mechanics. Your mechanics lo there are a lot of basic chapters ra. Ante vectors is there, okay? Your units and dimensions are there, basic mathematics is there. So these chapters ante ivanni physics lo, right from your starting till the end, these chapters will be useful. So if those chapters are weak, yeah, good afternoon. Okay, very good afternoon. So first try to cover your mechanics. Chala basics, okay, chala basics. At least till Newton's laws of motion. Kinematics 1D and kinematics 2D are there. You start all this, then if you want you can enter into electrodynamics and electrostatics and then your current, electricity, capacitors, all this stuff. Later you can continue from mechanics itself and then Newton's laws of motion, work power energy, circular motion, etc. Okay. Okay. Hi Isha. Hi. Very good afternoon. Very good afternoon. Okay. Perfect. So we are good to go with the lecture, kada? Yes. So we will be starting it. In the last class yesterday itself we have completed the rotational motion entirely, okay? Yeah, we will have a detailed discussion, okay? Akula Tejaswini, about the other career opportunity, we will have a detailed discussion. I have planned a session about that also, okay? I'll note it down. Okay, perfect. So yesterday's class we have completed the entire rotational dynamics chapter. You see it is 6 hours and something 10-15 minutes extra. Okay? Then we have gone till the scratch level and we have extracted every information that was possible. This chapter I'm just going to talk about electromagnetic induction. Chuskondi. If you have to understand yeah, you can start with class 12 also. Physics law you can start from class 12 syllabus also. Kani. If you see electrostatics chapter, electrostatics law, there is a question, okay? What is the question, sir? I have 3 different charges, 3 charges. Let us say plus Q1 charge is there, plus Q2 charge is there, plus Q3 charge is there. If you are told to find the force on any one of them, to solve this question in electrostatics, chapter is electrostatics, you understand, okay? Kani you need vectors, okay? So repulsion ante here, this force is here, angle theta unte, you have to talk about the resultant of the force. So vector plays a very crucial role into solving this question. So if you don't know anything about vector, you cannot touch this question, okay? You can start wherever you want to start. Kani basics matrame clear undale. Endukante your entire physics is supported on some basic chapters, okay? Basic chapters lo kuda, the most important chapters is your vectors, basic maths, units and dimension. If 3 chapters are perfect, then you can start wherever you want to start. But if you are skipping those chapters, if you are skipping your vectors, you are skipping your units and dimensions, your basic maths, you will not be able to do anything, okay? Anything. Anyways, chalo. Yeah, basic maths and vectors. Basic maths and vectors are important. Dan tarvata you can start wherever you want to start. Okay? Kani, hey, this name is having some problem. Anyways, Kani, I would suggest you to go and watch my lives. Array, Malli cheptunna, there is some reason why am I telling this to you. I've told this 5 times, at least 5 times in the last class. What did I say? Before starting the syllabus, go and start watching my live. Endukante we are doing it live ra. You understand? If you are starting with modern physics, I have not completed it yet. Understanding? If you start from some other chapter, I have not completed. I am with you ra. I am with you na. Then why are you going to some other chapters? First, clear everything that we have covered. Dan tarvata be with me. Ade, be with me. Just be with me. We will be solving PYQ questions. Deentlo I will be at least promising you 150 marks. Okay? Okay, perfect. Let it be. So, I am consistently telling everybody to be with me first of all. Dan tarvata we will be doing everything. Right? I am with me, right? I am with you. Sorry, I am with you. Anyways, chalo. So, sir, electromagnetic induction ante EMI, okay, monthly EMI, sir. EMI chapter study cheyadaniki your prerequisite is magnetism. Magnetism ante enti, sir? Gurtunda? Do you know, sir, magnetic effects of electric current. Ee chapter lo what did we study, re? We studied, sir, if you have a wire with current I, it creates a magnetic field. Ade kada? Yes. So, ee mottam chapter lo, what chapter, sir? Magnetism. So, ee mottam chapter lo, we studied that current creates magnetic field. Ade kada? Yes. This was our basic understanding, ra. This is something that we have talked about in the entire chapter of your magnetism. Ante enti, sir? B is equals to mu naught I upon 2r due to circle, your Biot-Savart law, mu naught I by 4 pi into dl bar cross r bar divided by r cube. All those formula, okay? All those formulas are only valid when your current is creating your magnetic field. Ante ide mee current ra, and it is creating what? It is creating your magnetic field B bar. Ade, so current nunchi magnetic field varaku, if you are going in that direction, the name of the chapter is magnetism. Magnetism. Ade, the name of the chapter is magnetism. Kani electromagnetic induction lo we are doing exactly the opposite of it. Ante we are saying magnetic field creates current. Magnetic field creates current, sir. Magnetic field creates current. Yes, not magnetic field ra. Chusko. Magnetic field does not create current. Kani change in magnetic field may create current. Ela create cheyali, sir? Change in magnetic field leads to change in magnetic flux. Magnetic flux. Oh, nice. Ante eppudu we are going to talk about magnetic flux. Chuskondi. Ante entira, the only thing that I am interested in this chapter, ee mottam chapter lo what I am going to study is how the magnetic field creates current. Ade. So here current is born ra. Ekkada magnetism chapter lo magnetism is born kada. Ee chapter lo current is born. Ade. The only thing, whatever 4 hours I am spending in studying this chapter, in mottam 4 hours lo I am just studying about how the current is getting created. Ade, nothing other than that. Okay, are you understanding? I am just telling you the goal of this chapter. Ee chapter study chesina tarvata you will have an idea of how the current is created from the magnetic field. Ante change in magnetic field. Are you understanding? Yes. So, sir, to understand all of that, we will have to study something known as flux ra. Chuskondi. Flux ante enti ra? Did we discuss something flux, sir? Did we discuss some flux? Sir, electrostatics chapter lo, when we were studying Gauss law, at that time we discussed flux. What was flux ra? Yes. What was flux ra? Cheppandi andariki. Sir, flux is nothing but గుర్తుపెట్టుకోండి అందరికి, all the times, whether it's electric flux, whether it is gravitational flux, whether it is magnetic flux, flux is nothing but the number of field lines passing from a given surface. Understand, the number of field lines passing through a given surface ra. Ade, what is flux, sir? Flux is the number of field lines field lines passing through లేదా passing through a given surface. So ఏం field lines sir? You have magnetic field, మీకు gravitational field కూడా ఉంది, and at the same time you have electric field also. Very good, very good. God of laziness, very good. Number of magnetic field lines passing perpendicular to the surface area is known as magnetic flux. అదే passing through a given surface is known as your flux. So ఇప్పుడు field lines, magnetic field lines ఉంటే it will be magnetic flux, electric field lines ఉంటే electric flux, gravitational field lines ఉంటే gravitational flux. అదే కదా, we only have 3 types of fields in your syllabus: magnetic field, gravitational field, electric field. అది అర్థం చేసుకోండి. అదే అంటే only 3 types of flux we will be talking about రా. దీంట్లో కూడా ఆల్రెడీ your electric flux has been completed in your electrostatics chapter. అంటే charges and fields లో there is Gauss law. ఈ point లో we have discussed about your electric flux. Okay, ఇప్పుడు we are talking about magnetic flux. చూసుకోండి. Flux is usually represented by the letter phi. చూసుకోండి. Flux is nothing but sir field. ఏం field గురించి మాట్లాడదు. Here in this chapter we are talking about magnetic field. అంటే B bar రా, B bar. Okay sir, so B bar dot area, A bar. అదే area bar. Sir, area is a vector sir. Area is a vector. Yes, area is a vector. So what is the direction of area sir? What is the direction of area? Area is a vector and the direction is, చెప్పండి అందరికి, this is something very basic రా. Direction is perpendicular to the surface. అదే సో దీంట్లో కూడా 2 కేసెస్ ఉన్నాయి. యూ కెన్ టేక్ వాట్ ఎవర్ యూ వాంట్, పర్పెండిక్యులర్ ఇన్వర్డ్స్, పర్పెండిక్యులర్ అవుట్వర్డ్స్. అదే కదా, ఇట్స్ గెటింగ్ టూ మచ్ ఆఫ్ కోల్డ్. చూసుకోండి. సో సార్, the question is find the flux in the following ra. Okay, find the flux for the following. We are starting from the scratch kada, so I am going to take all the possible questions. First case lo your magnetic field B bar is equals to okay, so it's a rectangle ra. Okay, rectangle lo your length vector is 2I plus j and your breadth vector is I minus 2k. Question is find the flux. చెప్పండి ఎలా క్యాలిక్యులేట్ చేయాలి. Do one thing, let us change one question. Okay? Should be 2I minus 2j. If you want, you can keep it. Okay? చెప్పండి. Yes, radially outwards, you can say that is the direction. చూసుకోండి రా. ఫస్ట్ ఆఫ్ ఆల్ మీకు ఏరియా కావాలి, ఇదే కదా. ఎస్, సో ఏరియా కుడ్ బి గివెన్ as L bar cross B bar. చూసుకోండి, క్రాస్ ప్రొడక్ట్ ఆఫ్ ద వెక్టర్స్, క్రాస్ ప్రొడక్ట్ అయినా యూ కెన్ సింప్లీ సే సార్ I bar cross I bar is 0, ఇదే కదా. ఎస్, లేదా యూ కెన్ ఆల్సో టేక్ డైరెక్ట్లీ యువర్ డిటర్మినెంట్ మెథడ్ IJK. ఇట్ ఈస్ 2 1 0, ఇట్ ఈస్ 1 minus 2 0, ఇదే కదా. ఎస్, So only your k term will be there. Chooskondi. I everything gets cancelled, j everything gets cancelled, your k terms remains. It becomes minus 4, minus 1 ante minus 5 k bar. Ide nee area vector ra ante minus 5 k bar is your area. Are you understanding? Yes. So ఒకసారి మీ ఏరియా వెక్టర్ వచ్చిన తర్వాత యూ జస్ట్ మల్టిప్లై టేక్ ద డాట్ ప్రొడక్ట్ రా ఫ్లక్స్ ఇస్ ఈక్వల్స్ టు సార్ బీ బార్ డాట్ ఏ బార్ ఇదే కదా. సో బీ బార్ ఏంటి రా, బీ బార్ ఇస్ 3i ప్లస్ 4j ప్లస్ 5k, టేక్ ద డాట్ ప్రొడక్ట్ విత్ యువర్ ఏరియా వెక్టర్ అంటే మైనస్ 5k ఇదే కదా. ఎస్ మైనస్ 5k. సార్ ఐ గాన్ జే గాన్ మైనస్ k అంటే 5k ఇంటూ మైనస్ k బికమ్స్ మైనస్ 25. సో దిస్ ఈజ్ యువర్ ఫ్లక్స్ రా, చూసుకోండి ఇదే మీ ఫ్లక్స్. ఓకే right, not k. In the dot product the ijk is not considered. Okay, chudandi, it should be minus 25 only. Dot product is a scalar quantity. Okay, question number 2 are ade question you have to find the flux only. Okay, choose kondi andariki ide na circle. Okay, this is a circle, so radius r is equals to 4 meters and this is my magnetic field line sir. B bar b is equals to, leda I can simply say sir 10 Weber kada field. The unit of flux is Weber. Choose kondi. Okay, 10 Tesla. Magnetic field ra, magnetic field. Okay, magnetic field cheppandi. The next question is something like this. Chuskondi. The question lo, this is your area. Okay, kani your magnetic field lines, they are passing something like this. DV ready. The total physics notes I will upload it. Okay, I will upload it. Don't worry. You don't have to work anything. Na daggara everything is there. Okay, I will upload it. And if you are in Telegram, be active in Telegram. Okay, all of you. Endukante I'll be posting, if at all I create any section of notes ante mottam from the scratch till the end, handwritten notes. If at all I create a section, I will inform that in Telegram group. So be available, be active in the group itself. Okay, group ante channel la. Okay, hi Varalakshmi, hi, very good afternoon. Cheppandi. So here ఈ కేసులో your area vector is towards the right అంటే perpendicular to the surface కదా. Yes, so ఇదే మీ area vector. ఎంత సార్ pi r square. Pi is pi only, r square అంటే 16 అంటే 16 pi is your area vector. Your magnetic field is 10 Tesla. చెప్పండి flux phi is equals to b bar dot a bar అంటే b into a into cos theta. కానీ ఇక్కడ చూడండి theta value is 0 ఎందుకంటే సార్ your area vector is in the right, your magnetic field is also in the right. So it is simply equals to b into a, b value is 10, a value is 16 pi ante your flux is equals to 160 into pi. Ide kada. Okay. Next, here is a little twist. Chusko. Your area vector is where ra? Cheppandi. The direction of your area vector, sir, it is perpendicular to the plane. Ade kada paina ki undi. Hey, area vector is in the upwards ra ante paina ki undi chuskondi. So this is your area vector. Andariki ardhamaindi. Yes, so sir, this is ide na area vector. What is the value of area, sir? Pi r square ante 4 pi. Ide kada. What about your magnetic field ra? It is 2 Tesla. What is the angle between area vector and magnetic field? This is a twist. Hi. Hi Anshu, hi. What is the angle between your area vector and your magnetic field? Cheppandi. Good afternoon, unique girl. Good afternoon. Hi Zarina. Hi. So sir, angle between area vector and magnetic field. Ide kada? Yes. What is this angle, sir? Hey, total angle 90 ra. 90 nunchi 37 ochindi. Remaining is automatically 53 degrees. Ide. This is the angle. Cos 53 enta, sir? Cos 53 is 3 by 5. 3 by 5. Values gurtundali. Okay? Not, yeah, very good. Very good, very good. Sin 37 లేదా cos 53. Okay, so you can simply say, sir, flux is equals to B into A into cos of 53 degrees. అంటే ఏంటి sir? Magnetic field is 2 and your area is 4 pi multiplied by cos 37 is 3 by 5. ఇదే కదా? Yes. So it is 24 pi by 5. So this is your flux రా. చూసుకోండి. ఇదే మీ flux. Your magnetic flux. అర్థమైంది అందరికీ? Yes. Okay. So sir, collectively I am telling you this. చూసుకోండి అందరికి చాలా important information. Your magnetic flux phi is given as, చూసుకో, hey all of you, your magnetic flux phi is written as B bar dot A bar. అదే కదా? B bar dot A bar అంటే ఏంటి sir? This is equals to your magnetic field multiplied by your area multiplied by cos theta. ఇదే కదా? Yes. Multiplied by cos theta. Okay. Hey, the space is not enough, ra. What to do? What to do now? Let us shift it towards a little. Okay, and then I don't want much space. Okay. So B into A into cos of theta. ఇదే కదా? Yes. So ఇదే. This is your magnetic flux ra. చూసుకోండి. What are the factors it is dependent on? చెప్పండి అందరికి. What are the factors? So sir, the factors that decide the flux అంటే the value of the flux are 3. మూడు ఉన్నాయి. చెప్పండి. What are the factors, sir? The first factor is your magnetic field. ఇదే కదా? Yes. So the first factor is your magnetic field. అంటే if you change the magnetic field, your flux will be changing. The second factor is your area ra. If you are changing your area, your flux will change. Third factor, చెప్పండి. What is the third factor? What is the third factor? What is the third factor? Sir, the third factor is the angle. Angle between them. అంటే theta. So if you change the angle, flux changes. అంటే these three are the parents of the flux. You change any one of them, flux changes. Are you understanding? Very good. అంటే the DNA structure of these three will be reflected in your flux. Are you understanding? Are you understanding? So these three are collectively the parents of your flux. Are you understanding? Bio students కదా? So మీకు మీ లాంగ్వేజ్లో చెప్తున్నాను, చూసుకోండి. Let us take one by one, okay? One by one cases చూద్దాం అందరికి. The first case is, if you change your magnetic field, ఏమైతుంది and how the things will be changing. Changing magnetic field. Change B bar. ఇదే నా first case. Second case లో what we are changing is, we are changing your area vector. Third case లో what we are doing is, we are changing the value of the angle between the two. అదే కదా? Yes. So when you are changing your magnetic field, ante your area and your theta should remain the same. See, we are only changing one factor at a time ra. Okay? Those JE people, they do some mischiefs ra. They change 2-3 factors. Ante they change angle also, they change area also at the same time. Okay? And they talk something. We don't have to do anything about it. Chusko. We are first changing only the magnetic field. Ante enti ra? Ante ee cases lo your area and your angle must be same ra. Same undali. Ade. This is the most important condition. Okay? Your angle and area are same, but magnetic field is changing. Ante enti sir? This is my area. Ide kada? This is my area, sir. Magnetic field enti sir? This is my magnetic field. Chuskondi andariki. Ide. And I am changing this magnetic field. Hey, చూసుకోరా. రెండు terminologies ఉన్నాయి. The first one is you're changing a magnetic field and second one is your variable magnetic field. Are you understanding? When you say B bar, there are two possibilities. The first is changing magnetic field, changing B bar, and the second one is variable B bar. Are they both the same, Are they both the same? Sir, changing is variable, sir. No, they are not the same, Are you understanding? Changing magnetic field ante your B bar changes with time, time. And here variable magnetic field ante your B bar changes with position. Hey, these are a small chinna hairline mistakes, okay? The differences that the students don't know. Variable magnetic field ante at each and every point the magnetic field is different. Ante each and every point ante position. You change the position, magnetic field changes, Ide kada. Changing magnetic field ante enti, sir? It is changing with time. It does not depend on the position. Are you understanding? So ippudu when we are changing the magnetic field ante we are doing the two changes, variable magnetic field we are not talking about it. Endukante it is not in our scope. Those idiots, they will discuss something like this, okay? Not in our syllabus and not in our scope. I am not going to discuss all these things. Variable magnetic fields unte you have to dig into calculus, integration, differentiation, all these things, okay? All these things. The second thing that I am only interested is changing magnetic field ante your B bar is changing with time. Chusko. It is chala important. Are you understanding what I am telling to you? So for example, sir, your magnetic field is B naught into T squared. It is changing with time kada. Yes. Area is A. Andariki. Okay. Area is A. Ippudu cheppandi what is the value of flux, Flux ki value cheppu andariki. So sir, flux is nothing but B bar dot A bar. Ante B bar dot A bar. Ante B into A ide kada. Endukante magnetic field and area, they are in the same direction. So sir, you can simply say B into A, B naught, B value entira, sir, B naught into T squared multiplied by area A, ante A, B naught, T squared. This is my magnetic flux that I got. Chusko. Kani, in case lo, your flux is changing. Enduku sir? Because your magnetic field is changing. Ante kada? Yes. Very good, very good. So in case lo, your magnetic field is as a function of time, ante me flux kuda, it is coming as a function of time. చూసుకోండి magnetic field change చేసిన తర్వాత automatically your flux also changes, Are you understanding? It is directly dependent on your magnetic field. Okay. What about the next case, sir? Next case ante change in area, చూసుకోండి change in area ante enti, sir? This is my magnetic field and it is not changing now. It's a constant magnetic field. Andariki. Try to understand it, okay? So this is a constant magnetic field, kani my area is changing. Area is changing ante entira, the radius of this circle is changing. Ekkada kuda the same thing. Changing ante entira, changing ante changing with time, not position. A position you can't talk about the change in position, Are you understanding? Your radius is changing, area is changing, ante entira, your radius is changing with time, ade. So enti sir, your radius could be given as r is equals to r naught into t squared. The best example. Ante ee case lo time value continuously increasing unte your radius is also continuously increasing. That means your circle is expanding. Are you understanding? Something like this, చూసుకోండి. Only focus at this circle, only focus at this circle. చూసుకో. It is only expanding kada. Yes. So this is your variable area example. Are you understanding? Okay. So this is your variable radius ante variable area example. In case lo kuda you can simply say, sir, magnetic here also you can simply say flux is equals to B bar dot A bar. Kani chudandi yaar, your magnetic field is into the plane, your area is also into the plane. In mottam same direction lo unte you can simply say, sir, it is B into A ante B is B only, kani area is variable. Area formula entara pi r square. Pi r square ante pi into mottam square pi into r naught t square whole square. Ide kada? Yes. So this is me flux, flux is equals to b into pi into r naught square multiplied by t to the power 4. So ఇదే మీ flux వచ్చింది కదా, చూసుకో. If your magnetic field is changing, area is coming as a function of time. మీ రేడియస్ చేంజ్ చేసిన తర్వాత కూడా యువర్ ఏరియా ఇస్ కమింగ్ యాజ్ అ ఫంక్షన్ ఆఫ్ టైం. ఆర్ యూ అండర్స్టాండింగ్? ద నెక్స్ట్ కేస్ లేదా ద లాస్ట్ పాసిబుల్ కేస్ ఈజ్ చేంజ్ ఆఫ్ థీటా. ఇప్పుడు థీటా ఎలా చేంజ్ చేయాలి సార్? హౌ టు చేంజ్ థీటా చూసుకోండి. అదే, సో దిస్ ఈజ్ మై మ్యాగ్నెటిక్ ఫీల్డ్. అందరికీ చూసుకోండి, దిస్ ఈజ్ మై మ్యాగ్నెటిక్ ఫీల్డ్ and this is my area. కానీ what we are doing is we are changing the theta. Theta అంటే ఏంటిరా? Theta is used primarily for the direction. Theta change చేయాలంటే డైరెక్షన్ చేంజ్ చేయాలిరా. ఎలా చేంజ్ చేయాలి? You simply rotate it. Rotate what? Rotate this circle. ఎలా rotate చేయాలి సార్? Something like this కదా? No. You can't rotate it like this ra. You have to rotate it like this. Are you understanding? You will have to rotate it like this, and this becomes the axis of rotation. If you have attended yesterday's lecture of rotation, then you would understand this is the axis of rotation. Okay? Yes, perfect. All right. Okay. So your circle is rotating something like this. చూసుకోండి. Hey, did I do some mistakes, ra? Hey, but you understand, okay? You are rotating it something like this. So after some time, the situation looks like this, ra. Hey, this would be your magnetic field. I'm watching this entire scene from this side. Ante, sir, this is my magnetic field that is going into the plane, okay? And this area has been tilted, something like this. Try to understand, ra. Ide na magnetic field, okay? And this is my area. Ela calculate cheyaleru. Hey, you understand? Okay, you understand. Leda, this is my area and this is my magnetic field. Are you understanding? In case lo, your area vector is like this, your magnetic field vector is like this, your theta has been changed. Ade kada? Yes. Hey sir, what are we talking? What are we talking? Okay, Nandini, we'll do it. Okay, we'll do it. So in మొత్తం కేసెస్ లో, sir, why are you running only behind changing flux? Why ra? చూసుకో. ఇక్కడ కూడా what did we do? We changed theta. ఎందుకు సార్? ఎందుకంటే we have to change flux. ఇక్కడ కూడా we changed the area vector. ఎందుకు సార్? Because we have to change the flux. ఇక్కడ కూడా we have changed the magnetic field. ఎందుకు సార్? Because we had to change the flux. Why to change the flux, sir? Why to change the flux? Because there was this experiment. What was this experiment, ra? The experiment said change in flux leads to generation of current. Ade, oh my goodness, generation of current. But sir, current ni flow cheyadaniki there must be a medium kada, oka medium undalira. Are you understanding? You cannot. Yes, very good. Generation of current లేదా induction of current కూడా అంటారు. Very good. Okay, very good. Sir, for the current to flow, there must be a medium. అంటే కండక్టర్ ఉండాలి. కండక్టర్. It must flow through the conductor, right? Yes. So basically, when you are taking the flux, చూసుకోండిరా, ఈ flux లో your three things are already assumed. What are the three things, sir? Your magnetic field, your area, your angle, రా. చూసుకోండి, దిస్ ఏరియా ఏ, ఏదైనా ఏరియా గురించి మాట్లాడితే దిస్ ఏరియా మస్ట్ బి ద ఏరియా ఆఫ్ ద లూప్ అంటే కండక్టర్. వాట్ ఎవర్ కండక్టర్ యు ఆర్ టేకింగ్, ఏరియా ఏ మస్ట్ బి దట్ ఏరియా ఆఫ్ దట్ కండక్టర్ ఇట్ సెల్ఫ్. చూసుకోరా, ఇఫ్ ఐ హ్యావ్ అ స్ట్రైట్ వైర్, ఓకే, ఇఫ్ ఐ హ్యావ్ అ స్ట్రైట్ వైర్, వాట్ ఐఎమ్ డూయింగ్ ఈజ్ I am bending it and I am forming a circle, ra. అరే, ఈ స్ట్రేట్ వైర్ నుంచి నేను ఒక సర్కిల్ ఫామ్ చేసిన. యూ అండర్స్టాండింగ్? whatever area this loop ante wire ante conductor, are you understanding? Whatever area this conductor is having, we are talking the same area in all the previous cases ra. Chuskondi, ide na loop ante ide na wire. Here also it is my wire, here also it is my wire. Are you understanding? Gauss law lo, when we were talking about area, we were assuming the imaginary area, understand? Kani ee case lo, when we are talking about area, the area is formed because of the loop. You are understanding? Good. Ippudu, it is not mandatory. Hey, Mr. Funny Boy, boring. Do you want me to dance? Huh? Do you want me to dance? Ranu ran antune sinnadu. Huh? Hey, understand, right? Hey, understand. Okay? Okay, understand. So, whatever loop you are having, loop ante conductor, okay? Wire. Oka straight wire nunchi, you make a closed loop ra. Enduku closed, sir? Endukante only the closed loops have area. Are you understanding? Okay, right, perfect. Okay, you can also take a triangle, leda oka square kuda, you can take whatever you want, okay? Kani oka closed shape kavali. Are you understanding? Take a wire, convert into any shape you want. Yedina shape teeskochu. Okay, perfect. Chusko. So if at all you imagine now, okay, ఇప్పుడు imagine చేసుకోండి. So this was my wire, sir. What did I do? I turned it, I bent into a circle ra. Okay, so I changed that wire shape into a circle. So ఇదే నా circle ఇప్పుడు ఈ కేసులో, and this is my magnetic field that I have turned on. Hey, when I say magnetic field, what do you understand ra? You can say north pole and south pole of the magnet, okay? One magnet, second magnet, రెండు magnets ra, చూసుకో. So these are the two magnets kada. North pole, south pole, north pole, south pole. Ekkada kuda north pole, south pole, north pole, south pole. Hey, these are the two magnets. Ante north, south. Sir, this is north, this is south. The magnetic field lines are flowing like this between the two. Ante I am taking the first magnet behind this board ra, chusko, something like this. Are you understanding? And the second magnet is here. This magnet is behind the board. Are you understanding? Okay. So, sir, when you talk about it, your magnetic flux comes into the scenario. Okay, your magnetic flux comes into the scenario. Chuskondi. But sir, there was the experiment. What was the experiment ra? Okay, what was the experiment? Chuskondi. Change in flux. Hey, what did I say? Change in the flux leads to generation in the current. Ide kada? Yes. So sir, na daggara oka loop unte, magnetic field unte, I do have flux, but I want to change it. Ela change cheyali? Moodu ways ra. There are three ways. Either you change the area, లేదా you change the magnetic field, or else you change the angle. Ante keep rotating that loop. Are you understanding? Yes, Faraday's experiment. Perfect. Okay, so change in flux, yedina change it is ra, it is giving an induced current లేదా generation in the current. ఇప్పుడు the question is, sir, where is the current flowing and how is the current flowing? You try to understand, okay? You try to understand this. It is chala important ra andariki. So if you are changing the flux ante, let us take the first case. First case ante enti, sir? Changing the magnetic field. So let us say your magnetic field is increasing. Hey, magnetic field increasing. That means magnetic field is changing. Ante magnetic field is variable. Ante flux is variable. Ante it should give me current. You understanding? Very good. The first case is something that I am taking in this session. Okay, your magnetic field is changing, ante flux changing, current induced, ante I got the current. Ippudu naku direction gurinchi maatladalira. Okay, so when you talk about direction, there is a law called as the Lenz law. Cheppandi. What is the Lenz law? Statement of Lenz law. What is the statement of Lenz law, sir? Okay? Yeah. Devi Reddy, don't worry, you'll get the notes. Okay? You'll get the notes, don't worry. What is the statement of Lenz law? Lenz law states, whatever change you do, Lenz law states, whatever you change you do, the system will act in such a way that the change is nullified. Hey, whatever change you are doing, the system generates the current in such a way that the change is nullified. Ante enti ra oppose simple languages lo cheptunna, the system basically opposes the change, ante resists the change. Chuskora. Okay, so whatever change you are doing, okay, you are increasing magnetic flux, the system wants to decrease it, resist, oppose, nullify. Are you understanding terminologies, ra? Okay, are you understanding? So whatever change you do, the current is induced such that the change is nullified. Now I want the direction from all of you. Okay, I'm just telling you the scenario. Yes, all opposite. Perfect. Ikkada chudandi ra. So if this is my loop and this is my magnetic field, okay, this is my magnetic field. Andarki cheppandi. So if you are increasing the magnetic field, ante B bar ki value increase avutadi. Tell me how the current will be induced. You understand one thing, okay? I'm telling you, hey, malli cheptunna, chuskondi andariki. If your B bar is increasing, direction gurinchi cheppu okkasari. Where is the direction of B bar? Into the plane. And B bar is increasing, ante it will nullify. Hey, how will it nullify, ra? It will say one thing, ra. Okay? The loop says that no problem. You want to increase the magnetic field, you increase. Okay? You increase. But I will also create a magnetic field. And that magnetic field will be in such a way that it opposes the increase. Ante entira. So if you are increasing the magnetic field into the plane, the loop will create another magnetic field out of the plane. So magnetic field out of the plane. Hey, chuskora. Increased magnetic field. Your increased magnetic field is into the plane of the paper. Ide kada? Yes. Then to oppose ra, ide kada? Oppose cheyadaniki leda resist cheyadaniki your induced magnetic field will be out of the plane. Ide kada? Yes. So ippudu you only focus on your induced magnetic field, ra. Hey, you only focus on your induced magnetic field. Where is the direction of induced magnetic field, sir? Outside. This is the direction of induced magnetic field. Ippudu, if this is my induced magnetic field, cheppu, where is the induced current, ra? Where is the induced current? Andariki cheppandi. So if this is your induced magnetic field, your direction of current, electromagnetism chapter, electromagnetism akkadi nunchi, your magnetic field along the thumb and your fingers give you the direction of current. Ante the current flows anti-clockwise leda counterclockwise into the loop. Ide kada? Yes. Very good. Ante entira? That means if you are increasing your magnetic field into the plane, your current will be anti-clockwise. Understanding? Perfect. Now, I'll ask you some questions. Let us see how many of you have understood. Which color today? Which color? Okay, this color. This. Okay, choose go. This is my loop, and this is my magnetic field. Okay, ఇదంటే the magnetic field is coming out of the plane. Induced current, okay? Current ante induced current. ఇదే నా ఫస్ట్ క్వశ్చన్ లా, దీంట్లో ఇదే నా ఫస్ట్ క్వశ్చన్. సెకండ్ క్వశ్చన్ ఇస్ దిస్, ఓకే? your B bar is decreasing, okay? Your B bar is decreasing. Third question lo, your B bar is decreasing. ekkada kuda your B bar is decreasing, okay? And last question, okay? Fourth question, your B bar is increasing. Cheppandi. First, second, third, fourth. Clockwise, anti-clockwise. Clockwise, anti-clockwise. Even before that, I have an important information to share. For everybody who has not registered for Vedantu All India Score Accelerator Test Series, చూసుకోండి. The dates were 4th of Jan, okay? దాని తర్వాత the second exam that has happened was on 11th of Jan, అంటే your last Sunday ra. And the third exam, that is the third series of this test, is actually scheduled on your 18th of January. చూసుకోండి అందరికి, okay? So for the students who have missed these two slots ra, మీకు ఒక ఛాన్స్ ఉంటుంది. You go and registered for this 18th January. When you are giving your session, when you are giving your examination, your score will be given. ఈ score tarvata your weak points, your conceptual mistakes, your calculation mistakes, they will be told to you. Ante kada? Yes. After that, the situation does not end here. You will also get your personalized sessions, okay? Your personalized sessions, andariki personalized sessions. ఈ సెషన్స్లో దే విల్ బి టెల్లింగ్ యూ అబౌట్ ద మిస్టేక్స్ దట్ యూ డిడ్ అండ్ ద మిస్టేక్స్ దట్ కుడ్ హ్యావ్ బీన్ అవాయిడెడ్. At the same time, you will have the idea about your own ranking national level low when you are sitting in the examination hall of your actual NEET examination. Where do you sit? Where do you stand? You will be coming to know from this test, okay? One last examination is on 18th of Jan, ante tomorrow itself, okay? The exam is tomorrow itself. So it is the last date. And if anybody who has not registered, go to the description section of this video. I don't know, Ira, whenever this word comes, I lag. Okay, go to the description section of this video. From the description section, meeku YSET ki registration links untundi. From there you click it. At the same time, there is a surprise for all of you, okay? Okay, at the same time, you go and you see there are different test series, okay? Test series. At the same place, you will also get the notes, okay? Notes. But for now, the biology notes have been updated. But I am trying to update the physics notes also. So, ante the total notes of physics, whatever we have studied, that will be available in your description section, all of you. So kasari click chesi whoever has not registered for YSAT, first go and register for it. Then go and see the test series at the same time, the notes whatever they are available. Kani, they will ask you to register first. And every student who is Vedantu student, Leda, my student, they must register, because what type of student you are, if you are not registered, at least you are understanding, okay, you go and attempt this test. And then let us come back to our original discussion. Chusko, your magnetic field is coming out of the plane. First question, right? The first question I'm talking about, okay? Okay. Bio syllabus has been completed. Really? Your bio syllabus has been completed, Each channel. Hey, I don't know. Okay, whatever it is. Chalo. So let us talk about this magnetic field only. Okay. Okay. It's okay. Perfect. Choose good. Your magnetic field is coming out of the plane, kada? Yes. And it is increasing. So what will the system do, What will the system do, sir? It will oppose. Oppose ante enti ra? Oppose ante it will say, hey, you want to increase outside, you increase. But. I will induce another magnetic field. Such that this change gets nullified. Ante ide na direction of the induced magnetic field ra. Ide kada? This is the only way. Through which you can identify the direction of induced current. You understanding? Okay, perfect. So if this is my induced magnetic field, what is the direction of current, ra? Take your thumb, right hand, okay? Take your thumb, current, okay? The direction of current. This is the direction of current ante clockwise. This question lo your magnetic field is decreasing into the plane, kada? Your magnetic field is decreasing. So how will the induced magnetic field, ra? It will try to oppose. Ante ikkada decrease ayindi kada? So it will try to increase. What direction lo ra? Internal direction. Ikkada kuda the same induced field, ra? Your induced magnetic field will be in the same direction, ante into the plane of the paper. Okay? If it is decreasing, it will try to increase. Okay? Yes. So if this is your induced magnetic field, take your right hand, thumb, your current will be again clockwise. Okay, so ikkada your current is clockwise. Here also your current is clockwise. You see here magnetic field baitigira, at the same time decreasing. So your system will try to resist it, oppose it, nullify it. Ante your system will try to increase the magnetic field in the outer direction. Ante this is the direction of my induced magnetic field in the outward of the plane. Take your right hand. Sir, this is my right hand. It is in the out of the plane. Ante your current will be anti-clockwise. Okay? Your current will be in the anti-clockwise direction. Andariki chuskondi. So if this is your magnetic field, this will be your direction of current, okay, in the anti-clockwise. And last case lo, your internal magnetic field is increasing. Your internal magnetic field is increasing. Ade kada? Yes. So if your internal magnetic field is increasing, the change, resistance, nullify, oppose, your induced magnetic field will be outside. Enduku sir? Because internal increasing, we have to decrease it. We have to take the opposite magnetic field. Ede kada? Yes. So ade outside current anti-clockwise. You are understanding? Ekkada kuda your current is anti-clockwise. Chusko. So this was the first way I was changing the flux. Ante endira? Ante by changing the magnetic field. Let us go for the second option, ra. What is the second option, sir? Second option ante change in area, ra. Oh my goodness, what you are talking, ra? Hey, change in area. Okay, so if your area is changing, your flux is changing. The system will try to induce the current in such a way that the change is nullified. You are understanding? The change is nullified. Ante entira? Ante if this is your magnetic field, I am taking all the two cases at the same case at the ssame time. Okay, students, shouldn't. You have filled the entire board with the magnetic fields. What are you doing, sir? First case lo, your area is increasing. Area increasing ante entira, radius is increasing. Leda your area is expanding. Ade kada? Yes. So that is your first case. In your second case, your area is decreasing. Okay? So in first case lo, your radius is increasing. Second case lo, radius is decreasing. That is the only thing that have been told to you. Now cheppandi the direction of current ra, induced current. The direction of induced current. First case lo, is it clockwise or anti-clockwise? Ikkada kuda is it clockwise or anti-clockwise? Cheppu andariki. Okay. So here the radius is increasing and the area is increasing. So if the area is increasing, flux is increasing. System does not like. So if the flux is increasing, it will try to decrease the flux. How will it decrease? How will it decrease, sir? The only option ra, chusko. The only thing that this loop can do is to induce one more magnetic field. It cannot do anything other than that. Are you understanding? So if your area is increasing, me flux guda increasing. Ade kada. So if your flux is increasing, it will try to decrease. Ela decrease cheyali, sir? You simply induce a magnetic field. In what direction? In the opposite direction. Ante this is the direction of induced magnetic field. Opposite direction kada. Enduku opposite direction, sir? Opposite direction lo tisi, you can simply say that the magnetic fields will get subtracted. Ante it will get decreased and the flux will try to decrease now. Okay, so if your magnetic field, induced magnetic field is outside, your current will be anti-clockwise, ACW. Choose kora. It could directly be asked in your examination. Okay? A loop placed in a uniform magnetic field perpendicular to the area, the radius of the loop increases, then the direction of induced current is dash. NEET 2027. Leda 2026. Are you understanding? You are understanding? Yes. Option A clockwise, option B anti-clockwise, option C no current induced, option D insufficient information. Yes. So if it is anti-clockwise, tell me in this case, right, if your radius is decreasing until your area is shrinking, ade kada. If your area is decreasing, your flux is decreasing. So if your flux is decreasing, this loop does not like ra. A loop, it will try to induce a magnetic field. In what direction, sir? In the same direction. It will try to add the magnetic field so that the decreasing flux is increased. The decreasing flux is increased. So your magnetic field is inside and your current will be in the clockwise direction. So this is your current, this is your current. Yes. Next, let us talk about the angle changing. Okay, change in the angle. Change in theta. Okay, change in angle theta. Ante, if this is your magnetic field, should I take it now? You have entire AC generator ante electric motor. In class 10th, Gurtunda, you had some motor. Deedlo you used to apply Fleming's left hand right hand rule and you try to apply that carbon brushes and that shaft and that loop north pole south pole of it, something like that. Hey, if you don't understand, leave it. Okay, leave it. If you don't understand, leave it. Hi, good afternoon. Just go. The last case through which I can change the flux is by changing the angle. Angle change ante you are rotating the loop. Ela rotate cheyali, sir? You must rotate it such that, choose. If this is your loop, wire this should be the direction of the rotation, omega. You are understanding? I am not going to take the mathematical aspect of it. Chusko. In the previous cases, we talked about the directions of current. Kani here, I am also not talking about the direction of current. Endukante the direction is alternating. Alternating ante enti sir? For one rotation, the current will be clockwise. For the next rotation, it will be anti-clockwise. You are understanding? You cannot say that the current direction is fixed. Okay. Okay. Prajwal, the lecture will be till 5 p.m. 5 p.m. Okay, 3 p.m. is done, right? Till 5 p.m. 1:30 to 5 p.m. 3 hours, 30 minutes, 3.5 hours, something like that. Just go. Let us talk about the Faraday's law. Faraday's law. Faraday's law. Yes, Faraday's law. Choose. Let us talk about చాలా ఇంపార్టెంట్ రా చూసుకోండి. వాట్ డస్ ఇట్ సే? వాట్ డస్ ఇట్ సే సార్? వాట్ డస్ ఇట్ సే? It simply says that, what is the statement, eh? Oh, Nandini, I did not see your text. I'm sorry, okay? Nandini, I did not see your text. Choose. Tell me the statement of Faraday's law. Andariki, what is the statement of Faraday's law? What is the statement of Faraday's law? Right. Perfect. So the statement of Faraday's law is like this. Chuskondi andariki. So let us take example, and along with that example, we will try to understand Faraday's law. Very good. Prajwal Yadav, very good. And Ray, who is it? Okay. Nandini, good. Hey, you've gone mad or what, Ray? What you are telling, the amount of substance deposited for liberated electrode is directly proportional to current passing through it, brother. You are talking about Faraday's law from your electrochemistry. Okay, that's a chemistry chapter. It is electromagnetic induction. It's a physics chapter. Okay, so here your Faraday's law is different. You understanding? Okay, so let us take a loop. Loop ante, this is my wire. Okay, this is my wire. Okay, this is my wire, and this is my wire. When I was in my class 12th, okay, when I was in my class 12th, when I was in my class 12th, there was a student, okay? A class of almost 100 students, okay? Chemistry teacher was teaching something, and Vadu, he is sleeping in the back of the class, okay, sleeping very calmly, and the topic that was going on was metallic properties of metal, okay? No, metallic properties. What are metallic properties, sir? That metals do have valence electrons, all these things, malleability, ductility, and all this stuff. the name of the title was Metallic Properties. He was sleeping. Suddenly his teacher noticed him. Hey, get up. What are metallic properties? Chappo. And what does he say? Sir, properties of metal are metallic properties. You understanding? Your class is going in some direction and your answers are in some other direction. You are understanding? The same. Choose. So when you talk about your Faraday's law, it simply says that మీ దగ్గర ఒక loop ఉంటే there is some magnetic field, okay? There is some magnetic field. If you are changing the magnetic field, ante if your B bar is changing, ante increasing, leda your area is increasing, leda your theta is increasing, decreasing, whatever it is, okay? Change. Ultimately, okay? Ultimately, what happened is, so his answer was not funny, but the laughter that started in the class, every student has laughed so hard, okay? As soon as he said, metallic properties are properties of metal, ade, understanding? Okay. No, metallic property ante enti ra? Conductivity, are you understanding? It conducts electricity. What else? So it has valence electrons. What else? Malleability, ductility, luster. He said metallic properties are properties of metal. Finished. Ante. Gone. Tata. Bye bye. Right? In case lo you understand, your Faraday's law talks about the current induced. Ade kada. Current induced ante you try to understand now. Okay, if you have a circuit, in circuit lo you cannot have a current ra. Let us say this is your resistance. This is only your circuit. Ante oka resistance and wire ade. You cannot have current. To flow the current, something is required. What is required? What is required ra? Chappu. What is required, sir? To flow the current in this circuit, you need a battery. You need a battery. Ante some EMF is required. Voltage is required. Ante kada? Yes. To flow the current, some voltage is required. Let us say this EMF is E, resistance is R. Ikkada cheppandi, current is equals to V by R. Ide kada? Yes. So we are not interested about current ra. We are only interested about EMF. Ante okkasari EMF vachindante current will automatically come. Okay? Okay? Yes. So you are only interested about the EMF. Ade. The Faraday's law talks about the same EMF. Ante ide na loop kada? It's a wire ra. Every wire has some resistance. Ante kada? So you imagine that there is some resistance to this wire. Andariki. Ante you can say that this is a bulb ra. Okay, this is a bulb. This is a bulb. Chuskondi. A bulb is attached. Okay? A bulb is actually attached to the wire and your magnetic field is changing. Let us say the magnetic field is increasing. Ante kada? Okasari magnetic field increase ayindante your flux is also changing. Flux is also increasing. That means according to Lenz law, current should increase. Ade kada? Direction also meeku telusa. Ippudu Faraday's law talks about the numerical things. Numerical things ante enti? Sir, whatever EMF will be generated in this loop, it will be minus d phi by dt. Ante rate of change of flux with respect to time. It is chala important ra. Very important, very important formula. You understanding? Yes. So whatever flux is induced, it is directly proportional to the change in the flux with respect to time. Ante kada? Yes. Good. Good. So let us take a question. All of you. Okay? Let us take a question. A coil of resistance 4 ohm is placed in XY plane. Full stop. Okay? A magnetic field, leda a variable magnetic field, a variable magnetic B is equals to 8t Tesla. Perpendicular to the lane. Full stop. Cheppandi. It's a good question actually. Okay. No option, right? No option is given. I want the answer only. Choose. So, sir, EMF is equals to d phi by dt. Negative sign only represents the direction. Choose. Ante entira mod of EMF is d phi by dt ante d by dt of flux. Flux enta icharu sir? Hey, I don't know. Okay, let us say the radius of the coil. Hey, radius e kavalira. You did not tell me about the information. You did not understand the question. Given radius is equals to 1 by 7 meters. And take pi is equals to 22 by 7. Everything gone. D by dt of phi kada. What is phi ra? Phi is b bar dot a bar. Ante kada. Ante b into a, simply b into a. What is b, sir? Magnetic field is 8 into t. Ade. Multiplied by area. What is area, sir? Pi r square. Pi into r square into 7 square. 7 7 gone ra. Ante 8t multiplied by 144 ante 2 t. This is the flux ray. Chuskondi. Ante kada. Yes. Next. So this is your flux. What do you want? You want EMF kada? So EMF is equals to d phi by dt. Ante d by dt of phi value entara 1142 into t. That is simply equals to 1142. So this is your EMF, sir. What about current, sir? I is equals to V by R ante EMF by R. What is voltage, ra? Voltage is 1142. What is the value of resistance? Resistance is 4 ohm divided by 4. Ade. Whatever answer it is the final answer of it. Okay. Next question, it has been asked in your PYQs. Okay, directly formula based question. Magnetic flux linked to a circular coil radius r is given by phi is equals to 2t cube plus 4t squared plus 2t plus 5 Weber. Okay. Magnitude of induced EMF, okay? Magnitude of induced EMF is dash. Volt, 192 volt, 108 volt, oh not 180, 108, and lastly 150 volt. Cheppandi. About what, Gunat? About A and A and T. Okay, I'm sorry, Gonat, I'm sorry. Yeah, I appreciate that. Hi. Hello. So 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Let us see. EMF is equals to d phi. Hey, magnitude kavalera minus d phi by dt ante it is indicating that the EMF is in the opposite direction of the current change. You understanding? Good. Very good. D phi by dt ante d by dt of phi. Phi value direct ichindi kada. So it is 2t cube plus 4t square. Okay. Hey, is it correct? At t is equals to phi ra. Hey. Oh my god. The question is incomplete, but the answers have been given. Idera, this is the question. I don't know. Plus 2t plus 5. And then differentiate ra. When you differentiate it, it comes out to be 60 square plus 8t plus 2 at t is equals to 5 seconds. Substitute the value. So 6 into 5 square into 25 plus 8 into 5 plus 12. Yes. So 6 into 5 is 150 plus 40 plus 12. 190. Are you sure? Am I doing some mistake? Hey, plus 2 ra, plus 2. Yes, this is a mistake that I did. It should be plus 2, not 12, plus 2. And next. Good, very good. 192. Gonad, very good. Okay, perfect. Now, let us talk about the case where the area is changing. Okay, area is changing at enti sir. Teeskondi. The radius of a circle leda the radius of a loop changes. Log t, okay, r naught log t, full stop. If an external EMF ఇక్కడ టైం రా ఓకే ఇక్కడ కూడా EMF here is also time here is also EMF here is also time here is also EMF here is also time graphs చూసుకోండి ఒకసారి your first graph like this your second graph looks like this your third graph like this and your fourth graph like this చెప్పండి లేదా you can take the fourth graph I don't think your chapter will be completed in one shot, right? Okay, very good, Gunnar, very good. I think we'll need one more lecture. I think I'll be only able to complete till your induced electric field. Okay, చూద్దాం whatever we can do. చెప్పండి సో let's zoom it out a little visible yes visible okay sir this is my solution చూసుకోండి రా so this is your radius and Okay. A little mistake from my end. I'm sorry. Okay, I'm sorry. A little mistake from my end. It should not be radius actually. It should be area. Area. Okay, I'm really sorry, all of you. For all who faced instead of R ఏరియా తీసుకోండి అదే ఫినిష్డ్ ఓకే ఐఎమ్ రియలీ సారీ చూసుకోండి సో సార్ యువర్ ఫ్లక్స్ ఇస్ ఈక్వల్స్ టు బీ బార్ డాట్ ఏ బార్ ఇదే కదా ఎందుకంటే ఇఫ్ యూ టేక్ రేడియస్ దెన్ ద గ్రాఫ్స్ విల్ నాట్ మ్యాచ్ ఓకే ఇట్ విల్ బికమ్ అ లిటిల్ కాంప్లికేటెడ్ క్వశ్చన్ అండ్ ఆ క్వశ్చన్ ఇట్ విల్ బి సూటబుల్ ఫర్ జేఈ ఓకే సో దిస్ ఈజ్ యువర్ ఫ్లక్స్ అంటే బీ ఇంటూ ఏ ఇదే కదా వాట్ ఈస్ ద వాల్యూ ఆఫ్ బీ రా బీ ఈజ్ బీ నాట్ సింపుల్ వాల్యూ బీ నాట్ ఏరియా వాల్యూ ఎంత రా ఏరియా ఈజ్ ఏ నాట్ ఇంటూ లాగ్ టీ అదే ఇదే కదా ఎస్ సో సార్ దిస్ ఈజ్ యువర్ ఫ్లక్స్ వాట్ అబౌట్ ఈఎంఎఫ్ రే చెప్పు అందరికి సార్ ఈఎంఎఫ్ ఈజ్ ఈక్వల్స్ టు అకార్డింగ్ టు ఫెరడేస్ లా d∅/dt ఇదే కదా మ్యాగ్నిట్యూడ్ ఆఫ్ ఈఎం గురించి మాట్లాడుతున్నాం ఓకే d∅/dt అంటే ఏంటిరా d/dt ఆఫ్ ఫై వాల్యూ ఏంటి సార్ బీ నాట్ టైమ్స్ ఆఫ్ ఏ నాట్ టైమ్స్ ఆఫ్ లాగ్ టీ ఇక్కడ చూడండి అందరికి బీ నాట్ ఏ నాట్ మొత్తం కాన్స్టెంట్స్ ఉన్నాయి బయటికి తీసుకోండి సో యువర్ సింప్లీ సే EMF is equals to A naught times of B naught times of d/dt of log t. What is d/dt of log t ra? What is d/dt of log t andariki? d/dt of log x. d/dx of log x is 1 by x kada. Yes. So you can simply say sir it is A naught B naught divided by 1 by t ante t ide kada. So this is your EMF. Chuskondi. It is inversely proportional to time ra. So EMF is inversely proportional to time. Ante enti ra? Which is the graph? Inversely proportional. It should be EMF is equals to k into t. Straight line kada. Miku graphs choose you should be in the position to write the equation of the graph also. Okay. Right. In case you can simply say sir your EMF is equals to minus k into t plus some constant c. Okay. Here your graph is k by t and here your graph EMF looks like something root t or something like this. Okay? So EMF is inversely proportional to T. Third case lo unte this is your answer. Okay, very good. Next. Okay. What did I say? Area changing. Okay, completed. Our question kuda completed. Now let us talk something about induced electric field. Andariki. Now I want your support ra. Chusko. Okay, I want your support ante attention ra. Induced electric field. It is chala important. There are 5 questions in your NEET that have been asked from this topic ra. Induced electric field. Chuskondi andariki. Induced electric field ante enti ra? Induced electric field. I don't know if you remember, Kani electrostatics chapter lo, our time lo I have told you something. What did I say? While we were discussing the properties of electric field, what did I say? While we were studying the properties of electric field, our time low, I told you one thing. Number 1, electric field never exists in closed loops. Gurtunda, I'm just giving you an introduction ra. Chusko. Ante it's a prerequisite. ఎప్పుడైనా ఎలక్ట్రిక్ ఫీల్డ్ని చూసి యూ విల్ నాట్ సీ దమ్ ఇన్ క్లోజ్డ్ లూప్స్. అంటే ఏంటిరా, ఇఫ్ యూ హ్యావ్ అ పాజిటివ్ చార్జ్ ప్లస్ క్యూ, ద ఫీల్డ్ లైన్స్ విల్ ఆల్వేస్ బి డైరెక్టెడ్ అవే ఫ్రమ్ దెమ్ అండ్ దే విల్ నాట్ ఫార్మ్ ఎనీ క్లోజ్డ్ లూప్స్. అంటే ఒకసారి ఈ లైన్ హ్యాస్ బిన్ కంటిన్యూడ్ అంటే ఇట్ విల్ కీప్ ఆన్ కంటిన్యూయింగ్, ఇట్ విల్ నాట్ టర్న్, it will not move in a circle, it will not take any curved shape. అర్థమైంది అందరికీ? Similarly, for a negatively charged particle Q, the field lines will be always directed towards this charge. అదే, you understanding? These field lines will never exist in closed loops. Kani, do you remember, Gurtunda, I told you that induced electric field lo, the field line always exists in closed loops. In what ra? In induced electric field, it is always exists in closed loops. I'm telling you here, and it will once again be revised in your electromagnetic waves chapter ra. Okay, EM waves. Perfect. It is same as your magnetic field kuda they also exist in closed loops kada. So ikkada vachi your induced electric field also exists in closed loops. Okay sir, ardham idi, but what is this induced electric field? I'll tell you. Stay calm and try to listen to me very carefully. Chuskora, you must understand, you must listen each and every word of me. And if you miss it, if you miss any single word of it, that's it, you will be losing the grip over it. Chusko andariki. This is my loop, right? Okay, this is my loop, andariki. And here is the magnetic field, chuskondi. And I'm telling you that this magnetic field is actually decreasing. Andariki chuskondi. If magnetic field is decreasing, can you tell me the direction of current? Can you tell me the direction of current? Be with me, all of you, okay? Be with me. If I say that this magnetic field is decreasing, can you tell me the direction of the current? Ade, that's my only question. If the magnetic field is decreasing, can you tell me the direction of current? Direction of current ante ee loop lo induced current ki direction kavali. So if the magnetic field is decreasing, the loop will oppose ante enti ra? Who? Neptune. చూసుకోండి రా. If your magnetic field into the plane is decreasing, ఏమవుతుంది సార్? This loop is not liking it. అంటే it will try to increase the magnetic field into the loop. అంతే కదా? Yes. So your induced magnetic field, hey, what I'm telling you now, I'm talking about induced magnetic field, not about induced electric field. Okay, induced electric field has not come into the scenario till now. I'm only continuing with Lenz law. Gurtunda? Lenz law. What did we say? If your magnetic field is decreasing, it is decreasing kada. So if your magnetic field is decreasing into the plane, it is decreasing. What will this do? It will try to increase into the plane of the paper ante your induced magnetic field will be increasing into the plane of paper. Ante kada? So if your magnetic field induced is into the plane, tell me the direction of current ra. Cheppu. Clockwise or anti-clockwise? Anti-clockwise or clockwise? So your direction will be in the clockwise sense. Okay? So this is the direction of current. Okay. I'm writing something on board kada. You all tell me, okay? You all tell me if I'm right or wrong. I'm writing something on board. Ante idi chala important things kada. So these are important things going on. And there is one of the students that is sitting on amongst you. You know what he is seeing? He is seeing these scratches. Okay? He is telling me that, sir, there are these scratches on the board. You understanding? Okay. Hey, let us continue on the topic. Chusko. So, when you talk about all these things, sometimes I feel, hey, chuskondira, okay? So, I'm asking you 3 questions. Okay? I'm asking you 3 questions. First question is, why was the current induced? Why? The first question is, why was the current induced? Enduku current ochindi? Okay? Why was the current induced? Tell me, all of you. First question చూసుకోండి అందరికి. ఈ 3 questions ని ఆన్సర్ చేస్తే your induced electric field concept will be clear. Okay? Very good. Very good. Very good. The current was induced because the magnetic flux was changed. Little more, little specific. Be specific. Magnetic flux is changed. It's okay. Kani, I want more specific answer. More specific answer. Cheppu andariki. Current was induced because the magnetic flux was changed, but it is not specific answer. Specific answer is current was induced because magnetic field was changed. ante kada. Yes, I got the first answer ra. Chuskondi, very good, all of you, very good. Current was induced because magnetic field B bar was changed. Ide kada. Yes. Then next question, what do you mean by current ra? What is current ra? What is current? What is current? Flow of charge. Flow of charge, ide kada. Yes, flow of charge, flow of charge. Good, not electron. You should not say electron. It's not flow of electron, okay? It's a flow of charge. Ade charge. Your electrons are not flowing in this direction. You understand? Mottam physics law, when you talk about the moving charge leda moving current, we only talk about positive charge. Ardhamaindi ante by assumption the positive charge is flowing in the clockwise direction. Ante positive charge in the clockwise. But do you know positive charge does not flow? Ardhamaindi kada. That means your electrons, they are flowing in the opposite direction. But I am not interested about electrons, I am only interested about positive. Chuskondi ante ఏదైనా ఈ వైర్లో పాజిటివ్ ఛార్జ్ ఉంటే దిస్ పాజిటివ్ ఛార్జ్ ఇస్ ఫ్లోయింగ్ ఇన్ ద క్లాక్వైజ్ డైరెక్షన్. ఎప్పుడు ట్రై టు లింక్ ఇట్, ఓకే? ట్రై టు లింక్ ఇట్, ట్రై టు లింక్ ఇట్. సార్ ద ఛార్జ్ స్టార్టెడ్ ఫ్లోయింగ్, ఇదే కదా? ఎస్. వై డిడ్ ద ఛార్జ్ ఫ్లో రా? వై డిడ్ ద current was induced? Current was induced ante charge was flowing, ade kada. So tell me one reason. Sir, why was charge flowing? Can I say charge is flowing because B bar was changed? Can I say that? B bar was changed ante current induced. Current induced ante charge flowed. That means B bar was changed ante charge flown, ide kada? Yes. You understanding? Are you understanding? Yes. So that means, can I make the conclusion ra? Chuskondi, 2 questions I have done, I have answered ra. So that means the conclusion is B bar was changed ra. B bar was changed, thus charge was flown. Ide kada? Yes. This was the observation. Ante this is the observation. So far so good, we have observed. Kani there is a little problem. You try to understand. You don't know about physics much, okay? Although you have been seeing my lectures, although you have been studying all these things, but I know about physics very good, okay? Not too expert, but I know some things, okay? According to my knowledge and according to scientists' knowledge, there is no proof, ante there is no direct link between change in magnetic field and charge. Ante enti ra? Ante enti? Sir, if you have a changing magnetic field, you imagine something like this, okay? You imagine something like this, all of you. So this magnetic field is increasing ra. Ide changing magnetic field. E variable magnetic field, changing magnetic field lo, if I put any charge, let us say it's a positive plus Q charge ra. I'm just placing it. I'm not doing anything. Just charge is placed and magnetic field is increased ra. Ideally nothing should happen. You understanding? Because as long as I know, ante the information that I have about physics, ante the information that scientists have about physics, according to that information, a changing magnetic field should not do anything to this charge ra. You understanding? It's a conclusion. Chuskondi, it's a battle ra. Ante it is a contradiction. What is the contradiction, sir? According to scientists, a change in magnetic field should not do anything to the charge. Kani ekkada kuda the change in magnetic field should not do anything to the charge. But your change in magnetic field is moving the charge. You understanding? Yes. We'll take a break. We will take a break at 3:30. We will take a break at 3:30, all of you. Okay? That means, sir, this change in magnetic field should not do anything to the charge, but it is doing. It is making it flow. You understanding? What do I know about flow? Ante motion of charge. When does charge move ra? When does the charge move? When does the charge move? When does the charge move, sir? You can't move that charge by taking your mechanics things. Ante you can't move a charge ante it is soul ra, soul, okay? soul to soul connect aitadi, kani if you cannot connect the soul with the body, understanding? If you have pure love, soul to soul attachment, you understanding? Attraction repulsion between the charge happens only due to their fields, electric field, you understanding? So if you have an electric field in the right side, E bar, you place a positive charge plus Q, it will automatically move ra. అంటే ఒక charge ని move చేయడానికి మీకు electric field కావాలి. You understanding? Okay. So to move any charge, ఒక charge ని move చేయడానికి all I know is, see, I know physics, right? I know physics, and in my knowledge it is that to move a charge నాకు electric field కావాలి. Without electric field I cannot move a charge. You understanding? So let us try to link ra. Okay, let us try to link up the things. This was a loop, magnetic field was changed, okay, B bar was decreased, current flowed. Ante change in magnetic field, you tell me, okay, change in magnetic field led to current. Ide kada, current ante enti ra? Current ante flow of charge. Okay, flow of charge. Ante flow of charge ante enti sir? Motion of charge. Ide kada, motion of charge. So that means, sir, if you have a change in magnetic field, it will move a charge. Kani, I don't know any such rule ra. If you have a changing magnetic field, it does not move a charge, but only electric field moves the charge. Ante this change in magnetic field gives rise to an induced electric field ra. Ade, so it is directly not affecting, it gives the rise to induced electric field, and this induced electric field is moving this charge. Understanding? Okay, perfect. So ఎప్పుడైనా whenever you are changing the magnetic field, అంటే it is giving the rise to induced electric field first. You understand? And that induced electric field is always existing in closed loops. చూసుకోండి. So if your B bar is decreasing, it will try to increase, అంటే your induced electric field is like this. You understanding? ఎప్పుడు whatever the positive charge particles are there into this wire, they will move along the induced electric field direction. You understanding? Good. Okay, very good. Okay, let us talk about some mathematical terminologies. Choose. You try to understand. Okay, you try to understand. All of you. This is my loop. Okay, this is my loop. అంతే కదా, this is a magnetic field. అందరికి చెప్పండి. And let us say this magnetic field is decreasing ra. Okay, magnetic field is decreasing. అంటే ఏంటి ra? That means your flux is decreasing. You understanding? Yes. What will happen, sir? Sir, according to Faraday's law, your EMF ante voltage that is induced in the circuitry, ante in the loop. EMF induced in the loop is nothing but minus d phi by dt. What is d phi ra? D phi is your change in magnetic field multiplied by area. If you are saying ra, the radius is r, చెప్పండి, your magnetic field is decreasing and your area is equals to pi r square. అంతే కదా? Yes. Substitute, all of you, substitute, sir. So EMF E is equals to minus d by dt of, చెప్పండి అందరికి, minus d by dt of your change in magnetic field multiplied by area is pi r square. ఏదైనా కాన్స్టెంట్ టర్మినాలజీస్ ఉంటే బయటికి తీసుకోండి అందరికి. So you can simply say, sir, minus pi r square multiplied by d by dt of b ఉంటుంది. ఇదే కదా, b is only left. చూసుకోండి all of you. What is this EMF, sir? EMF అంటే voltage అంటే potential రా. చూసుకో. ఎప్పుడు we will try to link the things, okay? We will try to link the things. EMF అంటే it is voltage, లేదా you can also say it is potential. Electrostatics chapter లో రా, I'm not interested about potential now. I'm interested about induced electric field. చెప్పండి అందరికి, induced electric field అంటే ఏంటి? If your B bar is decreasing, induced electric field is in the clockwise direction, something like this. So this is the direction of my induced electric field. Ante kada? Yes. I hope you are understanding, ra. And this induced electric field will be induced in the wire only, in the wire. You understanding? Ante if this is your little length dl ra, andarki chuskondi. If this is your little length dl, your induced EMF will be in this same direction E induced. Andarki chuskondi. Ante kada? Yes. Small length dl, induced electric field E induced. Voltage cheppandi ra. Voltage ante potential sir. V is equals to E bar dot dx bar. Ide kada? Hey, this is a formula in electrostatics ra. Standard formula, very standard formula, all of you. Okay? Yes. Ante your E multiplied by chinna length dl ra. Dl is dl only. Ide kada? Yes. Now understand, E and dl are in the same direction. Kabatti, you can directly remove the dot product, directly write E dl. So it is your small voltage dv ra. Ante kada? How many dls are there, sir? There are dl, 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 all of this, okay? All of this. Small dls are there. Ippudu em kavali? You do one thing, you try to integrate. So integral dv is integral E dot dl. Ide kada? Ante add all of it ra. Integral dv is voltage, sir, and that is E into integral dl. Why, sir? Because E is constant, by t ki teeskondi. So E multiplied by dl, 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 dl. Mottam dl integrate cheskondi. What do you get? Total length, 2 pi r. So this is your voltage ra. This is same as this voltage. EMF. Pick, substitute, sir. EMF is E multiplied by 2 pi r is equals to pi r square multiplied by dB divided by dt. Pi gone, r gone. Cheppu. So your induced electric field equals to r by 2 times dB divided by dt. This is your induced electric field formula. Okay, perfect. So ippudu let us take one question that was asked in your PYQs. Plus 7, okay? I'm preparing the questions by myself. Okay, andariki. అదే Okay, radius r is equals to 6 meters, and your magnetic field B is equals to 40 square plus 60 plus 7. Do it. At 4 seconds. Once we are done with this question, and then we will be taking a break. Yeah, let's just solve it and then we'll be done. Chepo, direct formula untundira for the induced electric field. Sir, R by 2 dB by dt ade kada? Yes. So induced electric field is R by 2 dB by dt. R by 2 ante 6 by 2 d by dt of B ade kada? dB by dt ante d by dt of B. d by dt is what, sir? 4t square plus 60 plus 7. So sir, 4t square plus 60 plus 7 ante 3 into 8t plus 6, that means 24t plus 18 at t is equals to 4 second kada? Yes, so 24 into 4 plus 18, 96 plus 18, 106 plus 8 ante induced electric field is 114 Newton per coulomb. Okay, right. We'll take a break now. చూసుకో. Hello everybody, hello. You there, yes. Hey, 2 minutes late only, Ray. Why are you... Time is money, sir, time is money. Okay. Perfect. So after break, we are talking about motional EMF and then rotational EMF. Okay, the first thing that we're going to talk about is motional EMF. Chudandi andariki. The first thing is motional EMF. Motional EMF ante entira? Hi. Hello everybody. 3 months left. Yes, 3 months left. You imagine, okay, let us say this is my magnetic field. Andariki. Ide na magnetic field. Okay. Sir, my magnetic field always cross, sir. Magnetic field ante always cross. Not moving EMF, motional EMF. Choose. This is the rod, okay? This is not rod. I'm telling you, this is the rod. Okay, sir, this is the rod that is placed in magnetic field. Okay, this rod is placed in a magnetic field, and I'm not just placing it. Let us do something. Okay, let us make some changes to assembly. Ante enti, sir? Let us say this rod is moving forward with a speed of v. Emaitadi, sir? What will happen? That's a question. Chala pedda question kada. Yes. Okay. Let us imagine. Okay, andarki chooskondi, right? It's a very important results now. Okay. Chala important conclusions. Hi. Ammulu. Hi. Choosko. So let us do one thing. I'm taking a positive charge. Positive charge ante telusara. See, physics lo positive charge ante chala important, okay? But we can't move it. Endukante, sir, positive charge is there in the nucleus of the atom. Ade kada? Yes. So what do? We can't move the negative charge. We can move the negative charge. Ade kada? But we will not move. Why, sir? Because we are too, hey, we will not move negative charge. You understand, okay? We can move it. We can move electron, right? You can take it out of the atom also, but we will not move it. Why? Because we love positive charge. And we will say, although this negative charge is moving, but we will say, no, it is not moving. Negative charge paina move chesinante, this positive charge is moving downwards. We say something like this, okay? We don't talk about motions of electrons. We only talk about motion of a positively charged particle. Why, sir? Because we love positive charge. Are you understanding? Okay. So let us imagine there is a positive charge, and it is moving. It actually does not move. Again, I'm telling you, I'm breaking that misconception itself, Chusko. When I'm telling that the positive charge is moving up, until the electron is moving down. You understanding? Okay? Yes. Okay, perfect. So, what you're gonna see here, chuskondi andariki. If this is a positive charge, all of you, okay, if this is a positive charge, you try to understand what I'm telling you, okay? Sir, this positive charge is having the value of charge is equals to E. Chuskondi, if you are understanding this or not. The value of the charge is E. Ide kada? Yes, the value of this charge is E. Now, what will happen? This charge is moving with a speed v, andariki. Sir, a charged particle moves in a magnetic field. A charged particle moves in a magnetic field. A charged particle moves in a magnetic field. Ante entira. There will be force on that particle. Understanding? What is the value of force, What is the value of force? What is the value of force? Cheppandi. Sir, the value of force has been discussed in the last chapter. Magnetism. F is equals to Q into V bar cross B bar. Gurtunda? Hey, do you know? F is equals to Q into V bar cross B bar. V bar ante speed of it. Gurtpettukondi. V bar ante speed of it. That means V bar towards the right. Ante the rod itself is moving towards the right kada. Yes. So V bar is towards the right. B bar is into the plane of the paper. So V bar cross B bar ante paina ki act chestam. So after some time, all the positive charge that was there, all the positive charge, it is experiencing a force in the upward direction. Ante koncham samayam tarvata, the positive charge gets deposited, ante gets collected at the topmost point of the rod. This is my positive charge. You are understanding? So all the positive charge, it is getting high. Hello. Okay. So it is getting deposited at the topmost point. What about the negative charge, sir? What about the negative charge? The negative charge similarly will come at the lowest position. Ante entira, the negative charge will be coming at this position. Chuskondi. So don't you think there is an imbalance between the rods? Ante imbalance between the charges ra. That means, sir, the positive charge is in the upward position of the rod, and all the negative charge, it has been shifted to the downward point. Yes. All the positive charge has been shifted to the top point. All the negative charge has been shifted to the bottom point. What will happen due to that, sir? What will happen? Hey, what will happen due to that? What will happen if the positive charge is upward, negative charge is downward? There is one more field. What field? What field? Chusko. If this is my positive charge, this is my negative charge, what is the field, sir? Electric field. Electric field. Electric field starts from positive charge and ends at negative charge. Ante kada? Yes. So electric field is starting from positive charge and ending at negative charge. Ante your electric field is acting from positive to negative charge. Ante kada? Are you able to understand this? Are you able to understand this? Okay? Yes. So ide me electric field. And this is your magnetic force, ra. This is your magnetic force. Are you understanding? Magnetic force is in the upward direction, electric field in the downward direction. Now I want to talk about this charge, re. All of you observe this charge. Andariki. This charge, okay? This charge. This charge. This charge. Now tell me the forces on this charge, all of you. Sir, electric field kindaki and the electric force will be downwards. You are understanding? And sir, magnetic field and the magnetic force is acting in the upward direction, sir. At equilibrium. Equilibrium ante entira? Equilibrium ante the forces become equal. Ade kada? Yes. Okay? The forces become equal. Ante entira? That means your magnetic force should be equals to your electric force. Magnetic force ante enti, sir? Magnetic force is Q into V bar. V bar is speed. Cross B bar should be equals to Q into E bar. Chuskondi andariki. Q gone. You understanding? Yes. Q gone. So sir, your electric field, whatever it's there, you got the value as V bar cross B bar. Andariki chuskondi. Eppudu I'm not interested in E bar. Naku potential kavali. What is the formula, sir? Sir, in electrostatics we seen V is equals to integral E bar dot dl bar. Ide kada? Yes. So sir, ikkada kuda you directly shift it and substitute it. V is equals to integral E bar ante entira? V bar cross B bar dot dl bar. You understanding? You understanding? Yes. So sir, potential V is equals to integral of speed V bar is speed cross B bar is magnetic field dot dl bar. Chinna dl bar teeskondi, you are left with the total length dl bar. Ide kada? Yes. Yes. So you can simply say, sir, potential V is equals to V bar cross B bar dot L bar. Ide. This is the EMF generated across, yes, any charge moving in a magnetic field will have a force. Absolutely. Yes. Yes. And that force F is equals to Q into V bar cross B bar, where V is the speed of that charge. Okay. Any charge moving in a magnetic field will have a force. Any charge moving in magnetic field will have a force. Okay, this is a force. You understanding? Okay, perfect. ఓకే చెప్పండి. సో దిస్ ఈజ్ ద వోల్టేజ్ రా అంటే ఏంటి సార్ అంటే యూ ట్రై టు అండర్స్టాండ్. ఓకే ఇట్స్ అ వెరీ ఇంపార్టెంట్ టాపిక్, చాలా 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 ఇంపార్టెంట్ టాపిక్ అందరికీ. చూసుకోండి. సో దిస్ ఈజ్ మై మ్యాగ్నెటిక్ ఫీల్డ్. ఓకే ఇదే దిస్ ఈజ్ మై మ్యాగ్నెటిక్ ఫీల్డ్. ఇన్ దిస్ మ్యాగ్నెటిక్ ఫీల్డ్ ఐ am హ్యావింగ్ అ రాడ్. లెట్ us say దిస్ ఈజ్ మై రాడ్ రా అందరికీ. చూసుకోండి. సో ఇదే నా రాడ్. ఓకే దిస్ ఈజ్ మై రాడ్ అంటే ఏంటి సార్, you do one thing. ఇప్పుడు I'm telling you the shortcuts. Okay ఇప్పుడు I'm telling you the shortcuts. Whenever you have a rod లేదా any complex shape, for this you must see my lecture of magnetic effects of electric current. అక్కడ కూడా we talked about force on a current carrying conductor. గుర్తుందా? on a current carrying conductor. What was the force ra? Sir, so many formulas sir, how to remember? F is equals to something like this. Do you know? Gurdunda, what was this L bar? L bar was the length of the conductor. Ade? No. What was this L, sir? Sir, L bar was the displacement vector from the initial and the final position of that conductor. Whatever it is, rod, semicircle, ring, disc, whatever. Okay? Anyways, ఇప్పుడు ఐఎమ్ గోయింగ్ టు టెల్ యూ సమ్ ఇంట్రెస్టింగ్ టాపిక్స్. సో చూద్దాం అందరికి. లెట్ us say you have a rod ra, and this rod is actually moving forward with a speed of v. మ్యాగ్నెటిక్ ఫీల్డ్ అంటే b bar, స్పీడ్ అంటే v bar. ఇప్పుడు ఏం చేయాలంటే యూ టేక్ యువర్ హ్యాండ్ అండ్ ట్రై టు ఫైండ్ ద డైరెక్షన్ ఆఫ్ v bar క్రాస్ b bar. ఏం చేయాలి? v bar క్రాస్ b bar కి డైరెక్షన్ ఫైండ్ చేయాలి. చెప్పండి సార్. v bar టువర్డ్స్ రైట్, b bar into the plane అంటే v bar cross b bar is పైన కదా. do the same thing పైన అంటే wherever the direction is you take the positive terminal అక్కడ. అంటే the పైన అంటే your upper direction is positive and the lower direction is negative. That means your entire rod is getting converted into the battery. You are understanding? Okay, you are understanding? Yes. Yeah, don't worry, I will provide the formula sheets. Okay, I will provide, don't worry for that. Okay, next చూసుకోండి. సో సార్ దిస్ పాజిటివ్ అండ్ నెగటివ్ టర్మినాలజీ సమ్టైమ్స్ క్రియేట్స్ కన్ఫ్యూజన్ ఇన్ ద స్టూడెంట్స్. యూ అండర్స్టాండింగ్ అంటే ఏంటిరా అంటే స్టూడెంట్స్ డు నాట్ అండర్స్టాండ్ విచ్ పాయింట్ ఈజ్ అట్ హయ్యర్ పొటెన్షియల్ అండ్ విచ్ పాయింట్ ఈజ్ అట్ లోవర్ పొటెన్షియల్. ఒకటే మాత్రమే యూ హ్యావ్ టు డూ వన్ సింగిల్ థింగ్ రా. వాట్ విల్ యూ డూ? యూ ఓన్లీ టేక్ ద డైరెక్షన్ ఆఫ్ v bar cross b bar. అదే వేర్ ఎవర్ ద డైరెక్షన్ ఆఫ్ v bar cross b bar is pointing, that becomes my higher potential region, and the remaining automatically migita comes out to be the lower potential region. Yes, Anjali, we will take formula sheets also. Okay, next. Let us see how many of you have understood it. Okay, let us see how many of you have understood it. Rod ra, this is my rod. Okay, this is my rod and it is moving something like this. Chuskondi andari, and it is moving something like this with a speed of v. Cheppandi, what is the direction of the positive and negative potential? Ante if I naming these 2 points ra, okay, the name of this point is point A here, and the name of this point is point B. The question is VA is greater than VB. VA is greater than VB అంటే potential at A is greater than potential B, లేదా VB greater than VA, లేదా VA is equals to VB. చెప్పండి which is correct. ఎలా ఫైండ్ చేయాలి సార్? You only do one thing ra, you only do one thing. What to do? Hey, thank you so much Ravi Kumar. ఏం చేయాలంటే యువర్ మ్యాగ్నెటిక్ ఫీల్డ్ చూసుకోండి ఒక్కసారి. మ్యాగ్నెటిక్ ఫీల్డ్ ఈజ్ ఇన్ టు ద ప్లేన్, యువర్ v bar is like this. Take the cross product, take your right hand, point them in the direction of v bar, curl into the direction of v bar. అంటే ఇదే కదా. That means this side is having higher potential, remaining side is having lower potential. అంటే VA is greater than VB. అదేనా చూసుకోండి. Are you understanding? మరి ఇప్పుడు ఏం చేయాలి సార్? You replace this rod ra, you replace this rod with a battery. You replace this rod with a battery. Ante your battery should look something like this. Left side higher potential ante positive, right side, hey, something like this. Are you able to understand? You are able to understand? Okay, right. Now I'm just giving you a question. Choose one. So the question is, find the current that flows through the given circuit. చూసుకోండి అందరికి. Okay, so this is the magnetic field. Hey, one more thing, when we are talking about this, the magnetic field must be uniform. Okay, yes. The magnetic field must be uniform, then and only then whatever we are discussing keeps the significance. Ledante everything will be gone. You are understanding? Okay, so this is my rod andariki. Okay, yes, to this rod I am attaching a resistor. Okay, this is my resistor. Let us say R is equals to 10 ohm. Magnetic field B bar ki value unte, sir, the magnetic field B is equals to 16 Tesla, right? Yes. And the speed of this rod V is equals to speed of this rod, let us say it is moving backward direction. Okay, V is equals to 4 meter per second. And length of this rod, for sure, L is equals to 10 meters. Okay, see the formula first of all. Andariki, what is the formula, sir? V bar cross B bar dot L bar. V bar cross B bar dot L bar. Andariki, V bar cross B bar dot L bar. I'm also giving you a hint. Choose kondi. The EMF induced in the rod is given as V bar ante speed, B bar ante magnetic field, dot L bar ante the length of this rod. Sir, L bar ki direction ante enti, sir? You can take whatever direction you want. Ante the direction of the current, leda the length along the the direction about. Yeah, that's what I'm telling to you. Direction of L bar, you take it either up to down, leda down to up. You are understanding? It's completely up to you. Okay, right. But I would suggest you, see, try to understand. But I would suggest you, when you are taking the direction of V bar cross B bar, andariki చూసుకోండి, V bar left, B bar into the plane ante V bar cross B bar is in the downward, kindaki kada, V bar cross B bar, you take the same direction as your L bar. Endukante sir, whatever direction your V bar cross B bar is having, let us say downward direction, downward. Your L bar is also in the downward direction. They both same directions unte, angle between these two becomes 0, and you can simply say, sir, it is equals to V bar cross B bar into L bar. The dot product is completed. V bar cross B bar into L. Take the direction of L bar in the same direction as V bar cross B bar. You are understanding? Yes. Now change. Just tell me the value of current, okay? Not 640 here. Hi, 640 is not. Yes, Nagalakshmi, mechanical properties of solid will be completed tomorrow. Repu itself, tomorrow or today itself, okay? Be present. If possible, I will schedule a lecture at 10 PM at night. Okay, Dintlo we will be completing mechanical properties of solids. 10 PM at night, a lecture lo we will be covering your mechanical properties of solids. Okay. ఇప్పుడు మీరు చెప్పండి, how do you solve it? లేదా I don't know if I will be complete. I think we'll need one more lecture. Okay, yes, correct. Varalakshmi, very good. 64 ampere of current చూసుకోండి. వాల్యూస్ పెట్టుకోండి ఒకసారి. సార్ V bar cross B bar అంటే ఏంటి సార్? V bar cross B bar అంటే VB sin theta ఇదే కదా. You are talking in terms of numbers now, multiplied by dot L bar ఇదే కదా. But you understand your V bar cross B bar and your L bar in the same directions lo unte, your dot product gets completed. You simply say VBL sin theta. చూసుకోండి. This is your EMF ra. ఇదే కూడా ఒక స్టాండర్డ్ రిజల్ట్స్ గుర్తు పెట్టుకోండి. When V bar, B bar and L bar, they are perpendicular to each other. చూసుకోరా. Where is your V bar, sir? your V bar is towards the left. Where is the B bar? B bar is into the plane, ide kada? Yes. And what about L bar ra? L bar is acting in the downward direction kada? Yes. So L bar is in the downward direction. Chuskondi. So this system, are you understanding? This is your V bar, this is your B bar, and this is your L bar. They are perpendicular to each other. Andariki chuskondi. They are perpendicular to each other. Ide kada? Yes. So, ee perpendicular to each other unte, you can simply say that in this special case, it comes out to be VBL sin theta. Ante VBL only ra, theta kuda 90 degrees kada? Yes. So, in that special case only, EMF is VBL. Ade. When is it possible, sir? If V is perpendicular to B is perpendicular to L. Chuskondi. You are understanding? Ante this should be your V, this should be your B, and this should be your L. They are perpendicular to each other. Okay, whatever it is. Perpendicular unte VBL. Ade. This is the same case in this scenario. Ade kada? Yes. Cheppandi. So, sir, EMF is equals to V into B into L. Speed was how much? Speed was 4. Your magnetic field was 16. It was length. Ade. So, EMF is equals to 640 volt. And ikkad nunchi I is equals to V by R. Ide kada? 64 amperes. Good. Now, let us quickly go through moving rail problems antaru. Chuskora. Okay. So, the name of the topic is moving rail problems. What are moving rail problems? Moving rail problems lo, the setup looks something like this. Chuskondi andariki. So, this are your rails. Ante these are the strips ra. Strips ante telusa? Strips. Metallic strips, okay? Metallic strips. These two. And here is your rod. Chuskondi andariki. Ide me rod, okay? This is your rod. And here is the resistance. Chuskondi. Ide. This is my resistance. Andariki. Resistance is R. Ide kada? Yes. Try to understand. What will happen now is, sir, we will turn on the magnetic field into the plane of the paper, something like this. Right? So, this is a magnetic field. What do we do now? Next to what we do is, we will be moving this rod. Chusko. It is moving with a speed V. Andariki. You are able to understand? Yes. Very good. Now, naku EMF kavali, sir. V bar cross V bar ki direction cheppandi andariki. So, magnetic field is B only. Cheppu. This is the length of the rod. Ante I am naming the length of the rod as L. Okay? Name of the rod is L. Now, cheppandi, what is the EMF generated? You can do it in two different ways. Yeah, two different ways. What are the two ways, sir? When you see in the first way, the area of this part, which area, sir? What area are you talking about, sir? This area. Chuskondi. This area, whatever this area is there. It is increasing, kada? Yes. If area is increasing, flux is increasing. If flux is increasing, EMF will be induced. Ade. So, what is after some time? Koncham time t tarvata, cheppu. After some time t, can I say that the rod has displaced by distance Vt ray? Yes, sir. Displacement is equal to speed into time. Constant speed untundi kada? Yes. So, this is the displacement of the rod. Next, sir, let us talk about the area. Cheppandi. What is the area that has been increased? What is the formula for flux, sir? EMF is equals to minus d phi by dt. Ante kada? Yes. d phi ante increase in the flux. Ante increase in the area multiplied by magnetic field divided by time. Ide kada? Yes. Tell me, what is the increase in the area, sir? This length multiplied by this length. Ide kada? Rectangle ra. This is the extra area that has been introduced. Ante your change in area is equals to length Vt multiplied by width is L. Ade. What about flux, sir? Change in flux is equals to B into change in area ante B into V into L into T. Ide. This is your change in flux ra. D phi leda delta phi. What about EMF, sir? EMF is equals to d phi upon dt. Ide kada? that means d by dt of phi ra. What is phi, sir? bvlt. Ade bvlt. B constant, V constant, L constant, by t ki తీసుకోండిరా. So EMF is equals to BV into L. అదే. Are you able to understand? Yes, yes. So this is the EMF generated, BVL, sir. నాకు కరెంట్ కావాలంటే you can simply say, sir, current is equals to I is equals to V upon R. అంటే I is equals to B into V into L divided by resistance R. ఇదే. You are understanding? లేదంటే you directly use this formula. What is the formula, sir? Formula is EMF is equals to V bar cross B bar dot L bar. They are the same, okay? You can go with Faraday's law also, లేదా you can use direct formula also, motional EMF formula. Cheppura, here if you talk in the scenario, చెప్పు V bar cross B bar. V bar cross B bar అంటే పైన కదా? Yes. So that means, hey, let me take one separate question itself. చూసుకో. So this is the resistance, andariki. Okay, these are the strips, and here is the rod. All of you, focus on it. Ide na rod kada? Yes. It is moving with a speed v, and magnetic field V bar is into the plane of the paper. Cheppandi, V bar cross B bar, upwards kada? So if it is in the upwards, that means you replace this rod with a battery that has a positive terminal upwards, negative terminal downwards. What is the EMF, ra? If it is moving with a speed v, sir, EMF is equals to V bar cross B bar dot L bar, length is L itself. Ade V bar cross B bar ante VB, simply VB ra, చూసుకోండి. They are perpendicular, V is perpendicular to B, B is perpendicular to L. You can simply say, sir, V into B into L. Ade, so this is your EMF. Current is equals to EMF upon resistance, ante VBL divided by resistance is R. చూసుకోండి. Same answer, you get the same answer, VBL by R. Here also you are getting the same answer, VBL by R. You are able to understand? So this was all about your motional EMF. Ante entira chusko. Ante if this is my rod, all of you understand, okay? All of you understand. If this is my rod, now I am little trying to drag you into the magnetism chapter, okay? What was the value of current you are getting, sir? Sir, B into V into L divided by R. Ide kada? Yes. So this was the value of the current. Can you, what about the direction? What about the direction of current, sir? Direction kosam take the cross product, sir, V bar and B bar into the plane. Ide kada? So V bar cross B bar ante paina. So that means the positive terminal of the battery will be upwards, negative terminal will be downwards. Ide kada? Ante the current will flow something like this. Are you able to understand? This is the direction of flow of the current. ఇప్పుడు now I will try to replace my original rod and I will try to check some things. చూసుకోండి, ఇదే నా rod కదా? Yes. So in this rod there is this current flowing in the upward direction. What is length, sir? Length of this rod is L. The current is I అంటే BVL divided by R. చూసుకోండి, చాలా చాలా ఇంపార్టెంట్. ఓకే, magnetic field is B. Magnetic field is B kada? Yes. Now do you remember, గుర్తుందా, force on a current carrying conductor, magnetism chapter, force on a current carrying conductor, F is equals to I into L bar cross B bar. Hey, something like this, this was the force kada? What is L, sir? L bar is the length of the rod, లేదా shortest displacement between initial and final points. ఇదే కదా? Yes. I value చెప్పండి. Initially I is BVL divided by R multiplied by length is L only and magnetic field is B only. Other, you are able to understand? So you can simply say, sir, V into B square L square divided by R. So this is the force. ఇప్పుడు డైరెక్షన్ గురించి మాట్లాడితే L bar cross B bar కి డైరెక్షన్ చూడండి. What is the direction of L bar? L bar కి డైరెక్షన్ is in the upward direction. B bar is into the plane కదా? So your force is towards the left. అంటే ఏంటి, sir? Your rod is actually moving towards the right. Due to this motion, there is a current. Due to the current, there is a force. And that force is opposing the motion. Ante moving, but force is towards the left. Motion, due to the motion, there was a current. Due to current, there was force. Due to force, the speed is decreasing. Ante after some time, the rod that was moving will stop. You are able to understand? Okay. If you are able to understand, good. Ledante, you leave it. Okay. JE topics, right? Next, let us talk about rotation. Okay, rotational EMF. motional EMF completed, let us talk about rotational EMF. Okay, rotational EMF and ఏంటి sir? Rotational EMF లో we will be rotating a rod. Okay, rotating a rod అంటే ఏంటి రా చూసుకో. So this was my rod sir. This is the axis of rotation అంటే hinge point అంటే axis of rotation ఇదే కదా. Yes, now it is rotating with an angular speed omega, something like this. చూసుకోండి. How to calculate? మొదటిగా డైరెక్షన్ గురించి మాట్లాడుతున్నా చూసుకోండి అందరికీ. When it is coming to the direction of the potential లేదా positive terminal, negative terminal, do the same thing. అంటే ఏంటి sir? Your omega is upwards అంటే your speed is upwards ఇదే కదా. Yes, so this is your V bar. Magnetic field is into the plane. Take the cross product V bar cross B bar towards the left అంటే your point A will be at higher potential, your point B will be at lower potential. Direction clear కదా. Remove it, you can replace it with a battery, higher terminal, lower terminal. Are you able to understand? Are you able to understand this? Hi. Lekha Sri, hi. Ante enti sir, if at all you have an assembly, ante if at all you have a rotating object that is rotating with an angular speed omega, it will create the potential difference across the ends. Ide kada? Yes, very good. Anjali, very good. So sir, what is the value of the potential difference? Ante naku VA minus VB kavalira. How to do it? So let us do one thing, okay? It is ippudu 5 minutes from here are for the students who are actually interested in physics. Ledante the students who just want to remember the formula, give the exam and crack it, you can ignore me for 5 minutes because it's a derivation part, okay? Not required. Okay, so derivation kosam let us do one thing. Let us go to a distance x and ikkada nunchi let us talk about a small distance dx ra ante idi length dx ide kada, right? Sir, the rod is performing rotation motion kani this small length is performing a linear motion sir. V is equals to r omega. R ante how much sir? Distance from the hinge point x. So sir, omega into x is the speed. Ade ఇప్పుడు let us talk about this dx length ra. చూసుకో, it is moving vertically with the speed v is equals to x into omega. Length is dx and magnetic field is b. What is EMF across these two ends ra? Sir, EMF chinta EMF d is equals to v bar cross b bar dot l bar. అంతే కదా. v bar అంటే how much sir? v bar is x omega, x into omega. b bar is b. l bar అంటే ఏంటి రా? l bar is dx. అదే. So this is the small EMF de. You are able to understand? So such small d add ante integrate cheyandi. So small de ante integral of d ante integral of x omega b dx. Ade your first de starts from 0 and last goes till the length of the rod l, 0 to l. Ide kada. Yes, take every constant outside ra. Okay, b omega outside, so b omega constant బయటికి తీసుకోండి. It is left with x into dx, 0 to l. ఇదే కదా. Yes, so b into omega multiplied by integral of x becomes x square by 2 and the upper limit is l అంటే l square by 2. అదే. So this is the EMF generated across the ends of a rod. Okay. Hi. Good evening Sindhu. Good evening. Yes. If you want to remember the proof, very good. లేదా you just remember the results. Okay, so if there is a rotation effect, చూసుకోండి. Okay, if this rod is actually rotating, length l, okay, hinge point is here and rotating with an angular speed omega, you must say that the potential difference across the ends of this rod is given as delta V is equals to B omega L squared upon. I think you are able to understand. Ante kada? Yes. What about the higher potential and lower potential, sir? Ante ee point A, ee point B. Cheppandi which point has higher potential ante how to do it ra? Same thing. You take a random displacement అంటే V bar cross B bar direction తీసుకోండిరా. V bar అంటే ఏంటి సార్? Your omega is like this అంటే your V bar is somewhere around this. ఇదే కదా. So V bar cross B bar towards the downward అంటే your VB potential at B is more than potential at A. అదే. Very simple, very simple, very simple. Okay? Right. Perfect, perfect, perfect. So ఇప్పటిదాకా whatever we have discussed, we've talked something about your motional EMF. అదే కదా, motional EMF లో we were moving the rod in a linear way. ఎక్కడ వచ్చి we were talking about your rotational EMF. చూసుకోండిరా, I am going to compare everything now. Okay, so this was my magnetic field, sir. So if at all I have a rod length L ra, speed V ra, magnetic field B ra, you can simply say sir EMF is equals to BLV. Leda the best formula is V bar cross B bar dot L bar. L bar ante enti ra? Length of the rod. Ade kada, length of the rod. Kani how will you do if the setup is like this? Chuskondi. This is my magnetic field. Ante kada. Yes, this is my magnetic field. అందరికి చూసుకోండి. కానీ I don't have a straight rod. ఈ కేసులో I have something twisted రా. This is my rod. It is moving forward with the speed V. చెప్పండి, ఇప్పుడు ఏం చేయాలి సార్? Will you take the total length? Will you take the total length? No. No. No sir, formula remains still the same. EMF is V bar cross B bar dot L bar. ఈ ఫార్ములాలో V bar అంటే స్పీడ్ ఆఫ్ ద రాడ్, B bar is the magnetic field, కానీ L bar అంటే the shortest distance between initial and final point. చూసుకోండి, V bar cross B bar in upward direction కదా. This is the initial point, this is the final point, is the distance L bar. అదే shortest distance between initial and final points. Are you able to understand? ఇక్కడ కూడా the same thing రా. Okay, motional EMF లో కూడా the things work exactly in the same way. అంటే ఏంటి సార్? If at all I have a magnetic field, and in that magnetic field, if at all I have a rod actually, okay, if at all I have a rod, and this rod is actually moving with some angular speed omega. So this is a hinge point, andariki chuskondi. Okay, and it is actually moving with some angular speed omega. What do we say, sir? We simply say EMF generated is B omega L square upon 2, where B is the magnetic field, omega ante angular speed, L ante the length of the rod. Ante kada? Yes. What will happen if this rod has been replaced? Ante this is your magnetic field. Okay? This is your magnetic field and this is your rod. Ante this is your rod. So sir, this is my hinge point ra, చూసుకోండి, ఇదే నా hinge point కదా, and this rod is moving something like this with an angular speed omega. ఇక్కడ కూడా the same thing. Don't worry, okay, don't worry. Here also formula remains the same. అందరికి చెప్పండి, what is the formula sir? Sir, EMF is equals to B into omega into L squared upon 2. కానీ L is the initial and final distance, displacement between initial and final point. చూసుకోండి, speed is in this direction kada. Hey, how should I tell you? Yeah, speed is in this direction ante V bar cross B bar, V bar cross B bar towards the right side, ante your DL bar should be initial and final vector this towards the right side. Are you able to understand? Yes. So this becomes your length bar, L bar ra ade. Okay, ledante you can substitute the values directly. Chusko. Now based on that, let us solve a question, all of you. Okay, question is find the current through the given circuit. CKT ante circuit. Okay, circuit. Semicircle ra. Okay, semicircle. This is a hinge point. Andariki chuskondi. This is a hinge point, and it is actually moving with an angular speed omega is equals to pi by 6 radian per second. Okay, pi by 6 radian per second. Magnetic field value, sir, B is equals to 1 by pi Tesla. Other. Okay, and the radius R is equals to 4 meters. ఇప్పుడు I want the current kada. Yes, so now I'll connect this with a bulb ra. Ade, only for the sake of connection I'm telling that it is connected to a bulb. చూసుకోండి. Resistance R is equals to 4 ohm. చెప్పండి, the current. Let us see how many of you can solve it. చూద్దాం, అందరికి చెప్పండి. అంతే కదా. ఓకే, చెప్పండి అందరికి, వాట్ ఈస్ ఇట్ కమింగ్ రే, వాట్ ఈస్ ఇట్ కమింగ్? ఓకే, చూడండి. సో ద ఫస్ట్ థింగ్ దట్ వీ కెన్ సే సార్, ఇట్ ఈస్ రొటేషన్, నాట్ అ ట్రాన్స్లేషన్ మోషన్ కదా. రొటేషన్ ఉంటే యువర్ ఈఎంఎఫ్ వుడ్ బి b omega L squared upon 2. What is the magnetic field, sir? Magnetic field is 1 by pi. 1 by pi. Omega ante pi by 6. Multiplied by L square ante the displacement between initial and final position. Cheppandi, idena initial position, idena final position. Are you able to understand? Ante 2r. 2r kada. Yes, radius value enta icharu. Radius is 4 meters ante 2r ante 8 meters. So it 8 square divided by pi gone ra, right? Yes, 8 square is 64 divided by 12 is your EMF, okay? Yes, you can divide by 2, later you can divide by 4, so it is 17 kada, 16 divided by 3, so your EMF is equals to 16 by 3. What about current, sir? I is equals to V by R kada. Yes, V is 16 by 3 divided by resistance value anta icharu sir, 4 ohm kada. So 4. So that means 4 by 3 ampere is the current. Ante 1.33333. Yes. 4 by 3, not 1.05. Okay, 4 by 3 ante 1.333333. So on so forth. It goes on continuing. Are you able to understand it? Okay, చెప్పండి ఒకసారి. How many students are watching? Right. Perfect. Okay. not 0.33, 1.333. ఎప్పుడు we are done with your motional EMF and your rotational EMF. The only thing that we'll be talking about is inductance. Okay, inductance అంటే self inductance, mutual inductance, and that's it. LR circuit, that's it. Okay, if possible I'll try to finish everything by this lecture itself రా. చూసుకో ఇండక్టెన్స్ అంటే ఏంటి సార్ చూసుకోండి అందరికి, all of you. Let us understand solenoid first. For understanding inductance, let us say this is my solenoid. అందరికి చెప్పండి, are you understanding the solenoid? Yes. Let us say, sir, number of turns per unit length is n. N is what, Ray? You must understand the terminologies as well. N ante number of turns per unit length. Ante enti, sir? There are n turns and the length of this solenoid is L. Ante n by L is given as small n. So length ante n and there are total n turns into the solenoid. You are able to understand it kada? Yes. ఏమైతుంది సార్ when I transfer or when I pass some current through it, చెప్పండి అందరికి. So if the current I is flowing through the solenoid, what will happen? Magnetic field is generated. Magnetic field is generated kada? Yes. What is the value of magnetic field, sir? Magnetic field is mu naught into n into I. ఇదే కదా? Yes. Very good. ఇప్పుడు let us talk about a single loop రా. There are n loops కదా? ఈ n loops లోంచి ఐఎమ్ ఓన్లీ కన్సర్న్డ్ అబౌట్ అ సింగిల్ లూప్ అందరికి. అదే యాక్చువల్లీ ఇట్ షుడ్ బి సంథింగ్ లైక్ దిస్. సింగిల్ లూప్ ఉంటే రేడియస్ చెప్పండి. లెట్ us say రేడియస్ ఇస్ ఆర్ రా. ఇప్పుడు నాకు ఫ్లక్స్ కావాలి, చెప్పండి. ఫ్లక్స్ ఇస్ ఈక్వల్స్ టు బీ బార్ డాట్ ఏ బార్ కదా, అంటే బీ ఇంటూ ఏ అంటే మ్యాగ్నెటిక్ ఫీల్డ్ ఎంత సార్? మ్యాగ్నెటిక్ ఫీల్డ్ ఈజ్ మ్యూ నాట్ n into I multiplied by area is pi r square. ఇదే కదా? Yes. So this is a flux through one loop. అదే కదా? Yes. How many loops are there? Capital N loops are there. చూసుకోరా, n loops are there. Total n loops. Length is L కాబట్టి small n is capital N by L. కానీ total loops are capital N only. అంతే కదా? సో ఒక లూప్ నుంచి this is a flux అంటే from n loops what will be the flux, sir? For n loops flux is equals to చెప్పండి mu naught n into I into pi into r square multiplied by capital N కదా? Yes. So this is the total flux. అందరికి చూసుకోండి. Are you able to understand? Yes. Sir, the total flux మళ్ళీ ఒకసారి రాస్తాను చూసుకోండి. Flux is equals to mu naught ni multiplied by pi r square first loop multiplied by capital N. What about capital N, sir? Sir, small n is capital N by L kada. So capital N is equals to small n into L. అదే substitute చేసుకోండి రా. So sir, mu naught n I into pi r square into n into L. ఇదే కదా? అంటే mu naught n square I into pi r square into L. This is the total flux that is passing through the solenoid. అంతే కదా? Yes. This is the total flux. చూసుకోండి. Hey, pi r square into L రా. Pi r square into L. Can you understand something? Sir, if this is my total solenoid, sir, radius is r and length is L. అందరికి చూసుకోండి. Length is L, radius is r. What is pi r square L ray? Volume of cylinder. Solenoid is also a cylinder. అంటే pi r square L gives me volume. That means, sir, total flux is equals to mu naught n square into volume ra. Okay, mu naught n square volume multiplied by current. ఇదే కదా? చూసుకోండి. mu naught is a constant quantity. Permeability of free space. n square అంటే ఇది కూడా constant quantity for a solenoid కదా? Total number of turns per unit length, that is also constant, and volume is also constant. Ante your flux is some total constant quantity, I am naming that constant as L ra, chusko, multiplied by current I. Ante can I simply say, sir, flux is directly proportional to current? Yes. That means when you run a current I, the flux that is generated, it is directly proportional to current. And the proportionality constant ante L, and this constant is known as inductance. చూసుకోండి. Are you able to understand? ఇప్పుడు I can say your entire circuit has been completed. Whatever we discussed, resistance, capacitance, inductance. Are you able to understand? Yes. అంటే ఏంటి sir? అంటే you can simply say your resistance, although the formula looks, చూసుకోరా, your resistance although looks like V upon R. ఇదే కదా? R is equals to V upon I. Capacitance C is equals to Q upon V. even if it looks that your resistance is dependent upon potential or current, it is not. Capacitance also, even if it looks that it is dependent on charge leda potential, it is not. Similarly, your inductance L, it is also not dependent on any external factor. And your resistance, your capacitance and your inductance, all of them, they only depend on the geometry of the substance leda material and the dimensions of it. Are you understanding? They don't depend on the current, they don't depend on potential, they don't depend on charge. You try to understand it, okay? Inductance ante entira, for a solenoid, చెప్పండి, inductance is given as mu naught n square into volume. అంటే ఏంటిరా, mu naught n square into volume is pi into r square into L. ఇదే కదా, mu naught n square r square pi L. It's a constant terminology. You try to understand, all of you. Are you able to understand? Yes. So this is known as inductance of a system. Okay. Perfect. So what will happen, sir? ఏమైతుంది sir? చెప్పండి. So if this is your solenoid, you try to understand what I am telling you. Okay. You try to understand. If your current I, మొదటిగా let us say I am connecting LR circuit కూడా అంటారు. Okay, let us say some resistance is also there. So inductance is L, resistance is R. చూసుకోండి, inductance గురించి మాట్లాడుతున్నాం కదా. So let us talk about unit of inductance is Henry. Hey, are you able to understand? For resistance unit is ohm, for capacitor unit is farad kada. Yes, and for inductance unit is Henry. Joseph Henry, this was a scientist on whose name the unit has been kept. Are you able to understand? Yes. So you try to understand now, when we talk about your circuit, LR circuit గురించి మాట్లాడుతున్నాం, చూసుకోండి. When we talk about your LR circuit, చెప్పండి, initially your battery was there, resistance and inductors were there. అదే కదా. As soon as I connect the battery, ఏమైతుంది sir? Okay, hey, D is not there. Okay, D is not there. Okay, D not there. చూసుకోండి. When I connect the battery, ఏమైతుంది అంటే the current should ideally start flowing. Okay, the current started ఇక్కడ నుంచి it started and it is ready to go up. It is ready to go to the right. కానీ as soon as the current enters here, it's a loop. Loop అంటే Lenz law అంటే ఏంటిరా, నా దగ్గర loop ఉంటే, if you have a loop, this loop does not like the change in the flux. You are able to understand? అంటే ఏంటి sir? అంటే if you are increasing the magnetic field, చెప్పండి, మొదటిగా when the battery was not connected, అంటే when the switch was closed. Okay, let us open the switch. Okay, when the switch was open, no current అంటే there is no flux into the solenoid. Are you understanding? Yes. When we close the switch, when we connect the circuit, some current flows దాని తర్వాత this flux will try to change. Here also flux is trying to change. ఏమైతుంది మరి? At that time this loop is not liking అంటే it will try to induce the opposite magnetic field. ఇదే కదా. Yes. ఒక సింగిల్ లూప్ కూడా ఉంటే it is trying to induce the opposite magnetic field to resist the change in the magnetic flux కదా. ఎక్కడ కూడా the same thing. This current, it will try to create the magnetic field అంటే magnetic field Okay. But there are n number of loops There are n loops. What will they do? They will resist. అంటే ఏంటిరా, they will try to చూసుకో, if your current is going like this, your magnetic field will be like this కదా. But your loop does not like it, కాబట్టి it will try to create one more induced magnetic field and the direction will be opposite. Understanding? So resultant ఏమైతుంది అంటే your current does not suddenly go into this resistor. అంటే ఏంటిరా, if it's a bulb, for example, instead of this resistor, if we take a bulb, okay, if it's a bulb, ante as soon as you close this switch, the bulb will not burn instantly. Okay, the bulb will not burn instantly. Emaitidi, rather instead of burning instantly, it glows slowly. Why? Because sir, because this inductor is not letting the entire current pass at a given time. Slowly it will allow, definitely it will allow. Can you the same the complex results చూసుకోండి. If your inductor అంటే this is your inductor. Okay, ఒక circuit లో you represent a resistance like this a capacitor like this, inductor, resistor, capacitor. LCR oscillations, they are called as LCR. We are not going to talk anything about that, okay? You just try to understand. So whenever a circuit is there, spring like diagram kada, it's a spring like diagram, right? It's an inductor. Chusko. So I'll just tell you the introduction. If you have a resistor, if the current I is flowing, chapandi andariki. What do we say? Ide na point A, this is my point B andariki. So I'll simply say, sir, potential across AB, potential difference across AB is equals to I into R. Able to understand? Good. If it's a capacitor, andariki, chapandi. This is my point A, this is my point B, charge on the plate is plus Q minus Q, and the capacitance is C. Chapandi, what will I say? Potential across the points AB is equals to, what is it? Q by C. Ide kada? Yes. Similarly, if you have inductor lo you must be moving some current I ra, okay? This I current should change. This I current should change. Ante enti sir? If the current I is continuously changing, this is my point A, this is my point B, you can say, sir, VA minus VB, and potential difference across AB is given as minus L di upon dt. Are you able to understand? So we are talking about potentials, okay? We are talking about potential differences. Dan tarvata we will talk about energies also, okay? Next, let us talk about energies. I'm just comparing everything, okay? Let us talk about energies. Number one, when you have a resistor. Number two, when you have a capacitor. And number three, when you have an inductor, okay? Inductance ante L, resistance R, capacitance C. Current I is flowing, charge is plus Q, here charge is minus Q, akkada kuda the current I is flowing. Are you able to understand? Yes. Chapandi, here energy stored ante heat energy, I square R into T, ade kada? Yes. What about here, sir? Sir, potential energy stored is half CV square leda Q square upon 2C. When you come here, in this case, your energy is half Li square. L ante inductance, I ante current. Okay? Okay, yes, we will be ending, okay? In 5 minutes, this session will be ended. Okay, perfect. So this was all about your inductance. There is something known as mutual inductance. You try to understand, okay? Mutual inductance. I'm just giving you the intro and then we will end up. In mutual inductance, what happens ante, if you have a primary coil, okay, mutual inductance lo you have a primary coil and then you have a secondary coil. Idena secondary coil, okay, secondary coil. Chapandi. Let us say the current I is flowing into the primary coil. E current, okay, sir. So if the current I is flowing into it, can I simply say, sir, there will be a magnetic field? Are you able to understand? Something like this, right? This is a magnetic field. Due to the current, magnetism chapter, gurtpetkondi. Try to remember it, okay? This is the magnetic field. Sir, if the magnetic field is increasing, ante, even through this loop, the magnetic field is increasing. Are you able to understand? But this loop does not like the increase of the magnetic fields. So what will it do? It will try to resist. 5 minutes, okay? 5 minutes. Okay. Hey, so what will it do? It will try to resist that change, kada? Yes. So basically, what can I say, sir? Sir, if this is primary current I1, this is current I2, చూసుకోండి EMF induced is E2. What will happen, sir? EMF induced E2 is directly dependent on the current I1 ra. Ante enti E2 should be equals to M into I1. Other. And this M is known as mutual inductance. Okay? So this is all about your chapter and we will end it. There is one more class scheduled. Okay, so students, thank you so much. And yes, for sure, go and revise every chapter. We will perhaps be having one more session at 10 PM. Our session we will be completing your properties of solids. Okay, properties of solids will be completed. Okay, if you don't have any doubts, we can leave this session. Okay, bye bye all of you. Bye. Bye, 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 everybody. Bye, bye, bye.